or is a heat. It was added to it.
Heat wouldn't
Or
cause gradient. That would just
temperature.
increase the pressure.
It
according to
wouldn't be
Boyle's law.
gravity because you can't prove gravity.
Yeah, it would
Yeah,
radiate out from the
gravity's
heat
not
source.
thing. It would be static, kinetic,
Yeah,
temperature,
that's actually not an
magnetic,
unfair point. I don't disagree with that.
electrical.
Let me know when you guys are done with this. I got something with
Yeah,
refraction.
electricity
Oh,
has
yeah, I'm
nothing
pretty
to
much
do with
done, because
temperature.
all I'm pointing out
Oh,
is
it
you
has
guys can't keep
everything to
saying.
do with it.
All
Prove
I'm
it.
pointing out is that you guys can't keep saying,
What's getting
gradient,
hot?
gradient.
What does that produce?
Gradient doesn't prove that you're contained or
It produces heat.
That produces energy, Berinder.
It's kinetic energy. It's not electricity.
Yeah, you just said it's not.
Wait,
It's just voltage, right?
Jin in
Berinder.
here?
No, it's not voltage.
It's not amperage. You don't get voltage and amperage from the sun, from light.
No.
No, you don't.
No?
You get heat.
Oh,
You get
okay.
heat.
Not from heat either. Huh? That doesn't convert.
You
What are
don't
your solar
get,
panels doing?
No,
they
never heard of them,
convert
probably.
they convert heat into energy.
Never heard of a solar panel before? Oh, okay.
Yeah, temperature is not electricity.
What's that doing?
Damn. Temperature is
What is
not
it then?
electricity.
So if you got a big vat of lava, you can't do no work with that? Oh, that's weird. You couldn't.
I
You
didn't
couldn't
say
have no
that.
power
I
with
didn't
that?
say. I didn't say
So
that.
if you boil all your water, it's not energy. It's not giving you energy when you boil
I
the hell
didn't
out of
say
that
it
water.
wasn't energy. I said it's not electricity.
You just said temperature isn't energy.
Demok, temperature is not electricity.
Oh, it's
By the way,
same.
solar
son.
He literally
It's
thinks
exact.
temperature is electricity.
Solar panels work by using photons of light from the sun to knock
How did we
electrons
get
across
from the pressure
semiconductor.
gradient to electricity?
Because
I
we're
don't know. I
talking
wanted to talk about
because we're
refraction
talking
real
to
quick.
flat earthers who are scientifically illiterate.
That's a claim right there.
No, that's what you are.
By the way, Jin,
No, no,
Jin,
that's
real
because
quick, just so
Gino
I don't
thinks
have to ever hear you make this claim, because you make this claim all the time. Can you just remember this conversation? Even according to your source on Wikipedia about the Van Allen belt, it's 2,500 rem, which is 25 sieverts per year exposure per year. Okay,
Yeah, I don't understand.
an acute exposure.
You've got it wrong.
The LD50 dose for a human, which means 50% of humans die with an acute exposure of
You're
5
forgetting-
sieverts,
you're
which
forgetting
is
something.
2 months in the Van Allen radiation belts. Okay,
You are
2 months.
forgetting something, mate. What you're saying is wrong because there is a third belt that you are not mentioning. There's a third belt, yeah, leftovers from the Starfish Operation Starfish Prime.
No,
Okay,
that's
yeah,
nonsense.
I bet you they
There's
didn't
no
know
third
about
belt
that.
left
I
after
bet you
that.
they had
That is
no clue about
nonsense.
that.
Yeah. Also, radiation
and-
exposure is lifetime, not just one. Not just one dose.
you.
And you get.
And
No, we're talking about an acute dose in order to kill you.
Yeah, but
go
it's
ahead,
also
Jin.
lifetime exposure too.
Yeah, we're not talking about that though.
Thank you.
There's some dudes who went back and forth.
Why
a
don't
few
you let him
times.
finish his sentence? Are you
So we're
afraid
not
of him?
talking about that.
They supposedly went to the moon. They would have been exposed to 250,000 rems just
Take a
from
breath.
that.
That's nonsense.
That's not
That's
true.
nonsense.
That's not
That's
true.
not the
That's not
level
true.
of radiation flux on the surface of the moon.
And I've sent you material to that.
That's
to that, point.
entertaining that the links you posted, Jin, actually disprove that claim.
Yeah, he
What?
doesn't
No.
know how to read.
You've got it wrong again.
It's a claim.
Your own
Jin can read in
source-
multiple languages.
Your own sources prove you wrong.
It's not my own
That's another
sources.
claim.
I'm going to
The
give you
links-
radiation
the links
in the
that
Van
you
Allen
put-
belts.
you again.
Your
No,
links,
you got it
your
wrong.
links prove
got
you
it
wrong.
You've got it wrong, gentlemen. You got it wrong.
Your links
Jin,
Because
prove
the
you
radiation-
wrong.
it states clearly that at 170 rems, the astronauts would have been vomiting and diarrhea in their suits and would have had vision impairment.
They didn't
2
get
months
170
after
reps.
that, they would have been dead. That's
They
what would have
didn't-
happened.
They
And I
didn't get
sent
that
you
much
them.
exposure.
And it's
had that
entertaining
much
that the
exposure.
one
You
source
get
you
sick before you
posted
die.
actually
Yeah.
stated they had below 5 rems, and the other one, I believe it was actually listed as
Look, there's 3
0.7
belts.
rems.
There are 3 belts. 3.
No, there's
belts.
not. No, there's not.
Yes,
No,
there is, Brenda. You
no,
loser.
there isn't.
There is 3
No, there
belts.
isn't.
You are wrong, Brenda. Do your homework. Once again, you
Brenda,
are
you're
wrong,
wrong.
Brenda.
You're a wrong human being. Get out of here. Fucking hell.
Once again, Brenda is wrong.
Completely wrong. Wrong gender, wrong everything. You're talking wrong. You're going to die wrong. Get out of here, man. Fuck's sake.
All right.
Jay,
I want to point out one thing. The centrifugal force demonstration I give was only to falsify that having a gradient inside of a container falsifies that claim. So by just pointing as a gradient doesn't mean that you're in an open system. And I just want to point out that we can demonstrate. Hold on. We can demonstrate also another way to have a pressure gradient without using centrifugal forces in a container as well. So there's multiple ways we can demonstrate this, but what the problem that you guys have is you cannot demonstrate inside a vacuum without containment. The gas is holding down to the surface of the Earth. Thank you very much.
That's your stupidness. Not only did Brenda not even know there was 3 belts, the moron, I bet you she didn't even know that it was man-made, that we created the 3rd belt. I bet you didn't know that either, Brenda.
There's no 3rd Van Allen belt. You guys are just making shit up.
This is the picture. There's an inner. There's only 2. There's only 2. There's the inner and the outer. There's only 2.
Wrong. And
there's the picture right there. There's the diagram right there. There's the diagram right there.
Go do your
Here we go.
Energy, guys.
We expect an
Has nothing
apology
to do with electricity.
You hung.
Radiation flux on the moon, 1.3 millisieverts per day. Okay, 1.3 millisieverts. You don't get acute sickness until you get to 1 sievert, which is 1,000 millisieverts. Okay, 1,000 millisieverts for acute exposure to induce sickness, and then to induce death, it's about 4,000 millisieverts or 4 sieverts.
You got it all wrong. You've got it all wrong, man. You definitely got it.
This is what all the data shows. Show me where there's a higher.
I'm giving you the details now. It's coming your way now. Read and weep, man. Read and weep. You ain't got a clue.
That.
You just haven't got a clue.
Okay, go ahead. Show me any source that shows more radiation than that.
I'm bringing it to your head now.
NASA. I can cite NASA.
When you look at it, I hope your eyes burn out with the radio.
Yeah, great. Go ahead, post it. I'd love to see it.
The Orion program, Orion 2, where they said they can't cross this area of space until they solve these problems. It would be lethal for astronauts to go there. Like dumbasses, you claimed you went there 50 years ago.
Yeah, they're talking about a modern vehicle using modern electronics. Okay, modern semiconductors that have semiconductors with traces in the nanometers, which is highly susceptible to radiation. Okay, they're not worried about the humans. They're not worried about the humans. They're worried about the computers on board.
So what about
use what you did last time then.
Be dangerous to the.
What about all these computers on the probes that they already sent out there? Those computers just made it fun.
Yeah, they're highly shielded and they're fully tested in a lab before that.
Yeah.
Did NASA say that it was last week?
Just like the spacesuits, huh? They test them just like the spacesuits.
Space gloves.
Yeah, satellites are space hardened, and they are specifically tested. They're tested extensively for radiation.
That tester, that roadster, that car, a red car just flown around.
Yeah, the car didn't have to do anything. It was a prop, so they didn't need to test the car because the car didn't have to produce any function.
Didn't have to do anything.
It was just a static prop.
They said it was a standard car.
They should if it didn't have to do anything.
The car itself didn't do anything. It was on the top of the second stage of the Falcon 9 rocket.
And it stayed in pristine condition in space.
It was strapped to the top of the second stage.
Okay, but it's in pristine condition in space.
Well, it's not like getting a.
Well, I don't think it's in pristine condition now after years in space, but it stayed in pristine condition for the few hours that we saw it from launch.
Yo, is my mic working, guys? Check.
Yes, your mic is working.
Yeah, you're good, Jeremy.
Quick question to Cret. What was wrong with the explanation of the glove and how they put restraints in it, and the fact that we posted the information showing how they developed the glove to work?
Yeah. If the glove don't fit, you must equip.
Yeah, this is fine. So
this is really what it boils down to. If I tell you, like, hey, I wanted to do this, but it didn't work. So you're like, oh, okay, well, sure. It didn't work. Listen, I'm trying to explain it to you, okay? So I told, listen, ready? I invented a new mousetrap, but guess what? It didn't work because it was too obvious. The mouse, wasn't lethal enough. I wanted to have a less than lethal thing. And I'd say, but I fixed it. And you're like, oh, okay, cool. How'd you fix it? Oh, here's a bunch of word soup. You're like, well, dude, did you actually try it?
I didn't provide work.
No, I
You're not
did.
understanding something doesn't mean it doesn't work.
Wait 1 second. I provided pictures. I provided evidence. I provided
Yeah, I haven't looked at.
explanation.
I got you. I haven't looked at the full thing yet.
You just brushed it away and made the
Yeah.
assumption. So
I
who's
didn't brush it
skeptic?
away.
You did. You just brushed it away.
No,
You
I
made
haven't looked at the full
you
thing
made
yet.
the throwaway comment earlier on, like they can't make gloves work in space, when we had a big discussion about how they did it.
Yeah, I haven't.
And-
You
and
posted a lot of
that's
stuff, and that's not
disingenuous, and
something.
that's brushing it away, Crit.
I didn't brush it away. I'll look at it later. I said you tagged everyone but me, but I'll be able to find it.
So Jin posted something in there. Okay, Jin, 170 RAM, which is 1.7 sieverts, which is what I said. You don't get acute radiation exposure till
You're gonna
100 RAM or 1.7 sieverts. Now show me where they measured
Did
a
you
level of
read
flux
on?
for
Hang
that
on.
much.
Did you read on? You would have diarrhea, vomit, and you would be dead in 60 days.
Yeah, at 170 RAM of exposure. Now show me where they got that much exposure.
Yes, you would be.
Okay,
Yes,
1.7 sieverts, 170 RAM. Show me where they received that much radiation flux.
They-
Show me any document that shows that's the radiation flux you would receive.
On the moon, it was 960 rems on the moon.
No, there is
No,
no
it
source
wasn't.
for that.
On the moon.
I just posted the link for you. It's just over 1 millisievert. It's
He
just over
makes-
1
he just makes shit
millisievert.
up. He just makes
That's
shit
also
up.
good.
yes.
What's also good
is
too is that when
BS.
they asked the actor, say, hey, how'd you handle the radiation? They said, oh, we just closed our eyes. Another actor said, what radiation? Like what? You were
Yes, it was
exposed to like
0.5 rems. Is what
no
they
idea what he was talking about.
Point
Like
five.
what? There's no radiation in space.
0.5 rems.
To them lie.
Point-
Listen to
There's
them
like, so
lie.
is it, yeah. So Brenda, if you went through 0.5 rems, would you say what radiation?
Yes.
Or would you say 0.5?
0.5 rems is basically.
Very good. Here's your sign.
0.5.
Look,
0.5
Now
rems.
look,
0.5
Here's your
rems.
sign.
0.5 rems
Do you
is
receive
not
any
enough to get you.
radiation?
I've just posted a couple of pictures there for you. Look at the two acetates, the color contrast. One's very sharp and the other one's thin. That was only at 5 sieverts. 25
So what?
rems. My mistake. 25
That's
rems.
25 rem. They were exposed to
25 rems, and the picture was
0.5.
The picture was
0.5,
already
not
destroyed.
25.
The negatives were
0.5.
look, You're not
0.5.
listening. You're not listening. You're not listening, though. Yeah, that was
don't
at
think you're listening,
0.5.
Jim.
Yeah, the levels were higher than that, and it destroyed.
They were not.
the
They were
negatives.
0.5,
Yes,
not
they were.
25. They
Talking
were
at fucking
0.5.
us now.
They were
Oh, yeah,
0.5,
the film,
not
too.
25.
You're
I
calling us
forgot about
lying
that.
gender ass. Go out of here.
Yeah,
man.
that,
Get out of here.
it was
The X-rays
25.
would have.
It
Gender
wasn't
bender.
25 rems. They were
Radiation is always over a period of time. You can't just say 25, or you can say 0.5 per day, or 0.5 per hour, or 0.5
It
per
was
year. You have to give it
exposed to
time.
25 rems. Okay, the man who
Yes.
did it. This is the man who did it. If you really want to know, I'll show you the guy who actually did the
So
experiment.
they were exposed
No.
to 0.5, not 25.
No,
Jen,
Yes.
Sorry.
Yeah, the film would have been
Sorry.
destroyed too.
bullshit. You're
Jen,
looking at your
Jen,
ass.
I work at a
0.5.
place. Jen, I work at a place and on machinery that
I'm
produces
sorry, I can't
that
take what
produces
you've got to say seriously,
that
my friend.
produces
Wasting your
radiation
breath.
every day. And
You're-
I have
you're-
to
you're
once a
wasting
month
your
check
breath
this
there, Mike.
radiation.
Don't
I know,
The
don't
hottest-
talk over me.
Just
I know.
wasted
I
your
know.
breath.
I
Don't even
work on
bother
this
talking
equipment
because
where
you ain't got a
once a
clue.
month. Once a month, I have to check
I'm
the
gonna
radiation on
take a
five
word from a man who
on
reckons. Yeah,
five
right.
machines.
Sorry.
I'll take pictures next week.
It doesn't
measuring
mean a
Jen,
thing.
Jen,
every
Doesn't mean
Jen,
a thing, I'm
your
afraid.
your own sources say 2,500 rem per year in the hottest part of the radiation
I'm
belt.
sorry,
Okay,
you
that's
got it wrong
0.3
again.
rem per hour.
got it
That's
wrong again.
0.3 rem per hour. 0.3
You
rem
got
per
it wrong
hour.
again.
Okay,
They were out on the moon.
on the moon it's far less. On the moon,
the whole journey took a fucking week. So you're talking out your ass. They're exposed for days in space, days on the moon. Okay, hours going through the Van Allen radiation belts. Don't tell me
Yeah.
you're talking out
at
your
a
ass.
rate, and we
Stop
just told
doing
you,
that.
0.3 rem per hour in the hottest part
Stop
of the
doing
Van Allen
that.
belt.
No, this is
0.3
perfect.
rem per hour.
No,
Point
I
three
read
rem
it.
per hour. You don't have acute exposure until 1,000 rem. Okay,
No, this is
0.3 rem per hour.
Guys, Listen, there's a perfect contradiction right here.
250,000 rems just as they leave Earth. They got to get through.
Prove it.
Yeah, there's a perfect contradiction right here because the other guy who just said he works around radiation and they report numbers far less than that. But yet somehow these astronauts said, what radiation? Oh, I closed my eyes.
Guys, real quick.
So
yeah,
which
you said
one
that.
is it?
You said
Was it
that.
radiation or not?
You said that a few minutes ago.
Real
quick.
Yeah, that was Alan Bean. That was Alan Bean that said that.
Some of our machinery has up to 45 REMs coming out of it. On some places, I have to check every surface of it to ensure that it doesn't go over a certain limit. But it is always exerting a particular amount of radiation. And once a month on each of my 5 machines, I have to take these readings.
You're not talking about 250,000 rems anyway. 260,000 rems, which would totally obliterate any human being ever to enter that kind of zone.
Nobody. That's not how much you get.
Yo,
Can I get one word in here while y'all are repeating everything?
Yeah, can I just ask real quick if anyone can post the main surveyor's refraction measurements in the text chat, please? Thank you.
Yeah, I'd like to get one word about the Van Allen belts. I thought they were a shield from the sun's radiation. So if you go beyond that shield, wouldn't the radiation levels go up?
Yes.
The Van Allen belts don't produce radiation. They shield the Earth from radiation.
Contained.
There's another contradiction.
They are contained within. This is the magnetic flux of the Earth.
Yeah, are you going to address my? Are you going to address my question?
The magnetic.
proof of that?
I am. Is the magnetic flux holds charged particles within the lines of flux, and because of that, there is radiation within the belts. That's where the radiation comes from.
Well, hold on.
How do you know this?
Is that demonstrable on Earth that happens or no?
How do you know this?
That's not what I was saying. Can I get back to my point?
My bad, Rocky. Go ahead, bro.
Because
that
was the answer to what they are.
The sun is supposed to be producing the radiation. So once you get beyond the shield, yes, it is. Once you get beyond the shield of the Van Allen belts, that radiation, those radiation particles don't have a shield. It has to go up. Your radiation exposure has to go up.
Those bands are containing that the particles that come from like the solar wind. So like a solar, when the Earth's hit from a solar storm, you see the aurora borealis. And those charged particles, they're contained within the Van Allen belts. So yeah, you're right that there's radiation that is out there outside of the Van Allen belts, but those Van Allen belts themselves are containing the material that came.
And they had no shielding.
And by the way,
Pardon me, but could you please clarify about the solar winds? Because his question gives indication he doesn't understand that.
Of aluminium, and aluminium offers no protection against.
Well, yes, it does, because it's particle flux. It's particle radiation, which is the easiest radiation to shield against, okay? The aluminum will not protect you against electromagnetic radiation like gamma and X-rays, but it does protect you against particle flux. And the majority of this radiation is...
into me, one of these people, like I was just muted for saying nothing. Again, and yet people love to shout over each other. What the fuck is going on with the moderation in here?
Foolish, dude, seriously.
What do we need to do here to not be muted?
This is Gem Panda's policy. This is how he wants it.
Exactly. So don't cry about it.
I want to know from Chemo, what do I need to do to stop being continually muted when I'm acting no worse than anyone else in this fucking server? What do I fucking need to do?
What you're doing right now
you need to leave.
Calm down.
Gamma behavior is just not going to be appropriate.
See, they want to take over the server.
You come to my face, Crit, and you call me a gamma, and I will slap you around like the little beta bitch you are.
Yo,
wow. They want to take over. They want to take over the server.
Right here.
Don't break.
That was some serious gamma right there.
They want to take over the server. That's what they want to do. They want to. No, this is how you do it.
That's a claim.
This is how
That's
you
a
do
claim
it.
right there. That's a claim. Prove that claim. Because I already told you while I was here. I said it was fun to be here. I enjoyed the roller coaster ride.
We're gonna bring it back to the radiation.
That's a claim, Brenda. You need to back that claim.
Right, dude, Crit. This is
But I want to know from Chemo, what do I need to do from stop being muted? Because I'm fed
Chemo
up.
said he didn't do it, bro.
Yeah, just make up, hug and kiss. You know, have a mano y mano talk. And
Why,
work it out.
Chemo said he didn't do it. They don't need a mano talk.
Yeah,
Chemo
but
said he
people
didn't do it.
other than Chemo have mods. We got
Well, I
flat
know how-
earthers with mods in here.
No,
I know you
That's
should
why
stop from being
That's
muted.
why.
I suspect
You got
Kosher
to say
just
stuff
muted
that
me
the
just now
Glovers
because
like
I
you to
was
say,
ranting a
and then
bit,
you won't be
and I
muted.
respect that. That's not a problem. What I'm asking Chemo is he keeps muting me when I don't say anything. I'm not doing anything.
It wasn't
or I'm not
Chemo,
acting any
I'm not saying
words.
it wasn't him, man. He's saying it wasn't him. But
Yeah,
like I
but
said,
there are other
what
people.
I said to you though is relevant. That whoever did it is looking at things like this situation right here. You kind of disrupted the conversation that was going
Well,
on.
then tell me what I need to do.
You have to introduce
I'm
us to your
asking the boss,
imaginary
what do I
friend
need to
named
do to stop
Gravity.
this happening?
You need to become a flat earther.
I answered your question. I don't know who did it, but this is an example of something.
Well,
that you shouldn't
the
do.
records will show who did it.
I don't have access to that.
Well,
I'm
you're a
always getting
mod,
rid of-
aren't you?
All right, so here's what's going to happen. The conversations that happen right now, we're going to go back to that. Your questions, those simple questions that you guys are asking, have already been answered.
Right.
I don't have access to that. I don't know who muted you. This is an example of something that of why not to get muted.
Yeah.
It's not that complicated. I think the conversation's over. Let's
Yeah,
go back to the
I
other
think
Can we
being in
can
the
we look
server
at
is
it?
over.
I sent an image of radiation going through paper, human body.
I
and
think that we should
steel.
just leave the server and let Jem
Man, you,
enjoy
Brenda.
all his
Brenda,
flat
shut
earth
up.
friends.
Look, I'll
Brenda,
say again,
that's some
I
serious
have-
gamma right now, Brenda.
Yes, I've sent an image for discussion. Look at it. The spacecraft aluminium offers no protection. Look at
That's
that
false.
steel RSJ, the I-beam, what we call in England an RSJ. Look at it. There's no,
There's no aluminum in that picture, dude.
yeah, but the aluminum was thinner than that RSJ.
Okay, paper is different from aluminum.
Yes, aluminum offers no protection to
False.
radiation.
That is false.
Yeah, but you're
Okay,
talking
it's
about
not
gamma
false.
radiation. We're not the radiation that we're talking about from the solar wind is not it's not electromagnetic radiation. It's particle radiation. It's not gamma and X-rays. It's like alpha and beta particles. Okay, helium nuclei. It's particle radiation, which is easily blocked.
Aluminium's not going to protect you.
Of course it will. A piece of paper will protect you from particle flux.
Yeah, right. I'm sure. 250,000 REMs that destroys negatives, right? It'll destroy, as little as 5 REMs.
Yeah, if
can
there's nothing
destroy
shielding the film, of course.
As little as 5
that
REMs
film is very,
can
very
destroy
sensitive.
negatives.
There's like a Veritasium video where he talks about how the first detections of atomic above ground testing was by Kodak because their film kept getting ruined in the can because it was being irradiated by the nuclear testing.
You can still
The
date
point is
people by the radiation in the body.
250,000 REMs would kill. It's clearly stated. You would die after. I've sent you the information.
But
You
what do you
die
got
after
exposed to that
1,000.
much radiation?
Yeah, you can figure out when someone was born based off above ground nuclear tests.
There you go.
That shit stays with you forever.
Yeah, I mean,
even in your grave.
Kodak
Even when
was
you're
having-
dead.
Depends on the radioactive
Kodak was having
Yeah.
a problem where their film was getting ruined in the container, and they had to investigate it, and that's because they were the first to detect the above-ground nuclear testing that the U.S. government was doing. But somehow, people
There
weren't
you are.
dropping dead everywhere because they were testing
Oh, you look at
nuclear
cancer rates.
weapons,
But
and
yet-
film was getting ruined.
And,
Look at cancer rates and
they went
illnesses.
to the moon. They went to the moon for several days, and nothing happened to the negatives at all with the Hasselblad camera. Nothing
Because it was
happened.
shielded,
Perfect
because
picture.
they
They
it
had
was
no
shielded
shielding.
to protect.
I repeat, they had no shielding. That's their own words. Very quick to say. Did the space
The
suits
storage
offer, hang on a second, please. Did the space suits offer any protection to radiation? No, they didn't. And you can ask Drummond. Okay.
Okay, but here's the
How-
difference, though, Jim. Here's the difference. Okay, the film that was ruined during the atomic testing, it was because it was being exposed to electromagnetic radiation. Okay, X-rays and gamma rays. Okay, that's not the type of radiation that was in the moon or the Van Allen belts, which was particle radiation, which is easily shielded by putting the film behind
Why
a material.
don't you Google it up and Google it?
I have.
In space, kill.
Listen, man, you're gonna have to start listening to people, man. He's giving you the information.
I've given you the
information. You should
I've
try to
given you the
listen to what he's
relevant
saying and
information.
see if you can understand it. And
I've given you the relevant information, and you don't understand.
He's giving you the relevant information, man.
You don't understand what I've given you. I've given you everything, even what happens to humans in space with that certain amount of radiation.
Shouldn't it be
and
up
what
to the
happens.
consumer whose information they
You're
want?
ignoring everything I've given you. You're ignoring it. That's what's happening. You're dismissing it.
Who
Because it
gets to pick
hurts,
the
doesn't it?
information that's right, Kosho?
Yep, I'm giving you everything correct. I'm not coming in there half-cocked. Fully coming in and blasting you people. Fireman's hose.
But Jin, you got your you got the radiation levels wrong by a standard deviation, mate.
I haven't, mate. Don't you worry.
No, you have.
I have not.
I'm afraid you have.
You are completely and utterly mistaken. You've
Um,
got it wrong.
The
I am
evidence has
not
been posted in the chat
I'm
for
not
you, Jin.
mistaken by the levels
You are
of
mistaken, Jin. You are wrong.
He has not.
radiation that's
Do we
out
have
there.
live
According
demonstrations
to
of
what
any
proletariat.
type
He
we're
of,
has
being
not.
told. According to
or
what we're
just
being told.
cartoon
According to what
More
we're
than
being
the
told right
proletariat,
now.
mate.
Sorry. And
I like live demonstrations and real vacuums and real showing and real tests for like days and months and a year before they go. You know what I mean? Real stuff. Cartoons
real
are
quick.
cool, you guys, but you know, hey, fuck that.
Druss, you got the refraction measurements for the main surveyors, plumb lines aren't parallel thing you did against
I'm
Witsit?
finding yourself, Jeremy, not your fucking sea line.
I was just wondering if you had it off the top of your, like in the top of your list or something.
No, my desire to be helpful towards flat earthers is retreating fucking rapidly. It's a bit like watching the tide go out at Huntshampton, mate.
Wouldn't that be called an inability to help us with any real evidence? That you don't have any? It's not possible for you to retrieve any real evidence other than 4 minutes long?
4 minutes long is nothing. Usually, fucking flat
We'll
earthers
give-
provide 3-hour-long videos.
Well, give
so
us the slow motion hour-long footage of videos of people being in vacuums and going up and down and doing their stuff.
Yeah, that's right. Let's see it.
Before they ever went to the moon. Let's get all the stuff. Let's get all the video. Even today when they're testing. Aren't they doing new tests today for new stuff and new materials and new things and new
Yeah, all the
vacuum
time,
areas?
dude. All the time.
Let's see this happen. I'd like to see one of you guys.
There you go, Jin. Andy's posted in the chat.
I'd like
from
to see one of
Science
you
Direct
guys
the
live
amount
do
of
it.
radiation you're gonna get, and it shows you're fucking wrong, mate.
Like to see one of you live motherfuckers I know is a real person get in there live with your camera on, in the suit, get in the vacuum and play around for an hour. Then come back and talk to us.
Sure, pay for it. Pay for it, Demok. I'll go and do it, mate.
Pay
I'd
for
love
the
to.
air to be sucked out of a room. Oh man, that's got to be so expensive. Let's see a pump.
I will treat that with the level of intelligent response that it deserves.
Yeah, the same response it deserves when people make a gravity chamber right there in their house with a pump, right?
And showing rockets
They just
working in
pump the air
space.
out,
You
right?
could just make one a little bit bigger, put yourself
We got
inside
miniature
there, take
rockets,
yourself
bottle
down to a
rockets,
vacuum.
all kinds of stuff, Rakia. We got little rockets. We can do little toy rockets, little toy planes, little toy jets, little toy stuff in a vacuum, a big vacuum. You guys got the big vacuum. It's sitting there being useless right now.
And
Nobody's
they
doing
test
nothing with it.
equipment in it that goes up into space.
They
It's the satellites that we produce that rotate around, that orbit around our Earth and provide us lots of lovely data that we utilize every day. And I've yet to see a good reason to doubt that, apart from you guys going,
I've yet to see them test anything
or
in a
an
vacuum live.
incorrect assertion that it's contravening the second law of thermodynamics for some fucking reason.
Can you show us what you're talking about for some reason?
Hey,
Or is
wow,
it
it's
just
only
your imagination?
$175 to go do that.
To what? Hear your imagination?
No, the
Yeah,
astronaut
170.
training.
You got to
There you
pay
go.
to see
They're
an astronaut
$175.
train when
Whereabouts in the
America
US
already
is it?
paid for them to go to the moon and everything else? What do you mean?
It's a 4 to 5 hour program, $175.
No, listen, moron. Where are all the fucking
are no
year-long video
astronauts.
footage tapes of all the stuff that they trained to do? It's already there. You don't have to.
Yeah. Why was
There's
there
only
not muted?
astronauts.
Sorry, why was there not muted? Because that seems a bit unfair. He wasn't over talking anybody. He wasn't doing anything wrong.
because he's Demok.
It's not that unfair for that
He was
reason, but I
muted?
still think That was a bit mean.
They always mute me. They don't like it when I ask them for evidence.
Hey, mate, I can relate to you there. There's this point we
I
can
know.
empathise on, and when I feel you're in the right, I will defend you, mate, because I'm a reasonable human.
Thank you.
Yeah, let them
Trust,
talk his shit.
Trust, I
Expose the
honestly
globe.
think I honestly think I have an argument against that those refraction measurements the main surveyors have.
Well, tell us.
Let's hear them.
I don't have the measurements.
I have an
What
argument.
do
Oh
you
wow!
need,
I don't have the
Jeremy?
measurements yet. You could defeat it.
Wait, no, no.
Yeah.
How would the refraction measurements help you, Jeremy?
They would help. I need the measurements because I don't
How
have an
would they
argument if
help,
I don't have the
Jeremy? How would they help even if you had them?
You don't.
Well,
have
if you're making a horizontal line with light, and there's a pressure gradient on one side, and then at the source of the light, and then there's a different pressure gradient where you're viewing the light from, right? Are those the two measurements we got from the main surveyor?
What numbers would you plug in?
I don't know. I don't have the numbers. That's what I'm telling you.
What Okay, what formula are you using?
I don't know. That's why I just need the refraction measurements from the main surveyor.
He has
See-
no
see,
clue
most
about
people,
anything, so you're wasting your time talking to him.
Most people can put forth the formula before the numbers to plug into it.
Just might
That's
know
how
more
I-
about the methodology.
I asked Just nicely, but he was in a heated moment, so maybe later when he
No,
cools
but he
off.
might not have the numbers offhand, but he might know more about the methodology in terms of like collecting the
But Jeremy,
refraction at both
refraction,
locally at both stages.
refraction will make
So
those
one of the
numbers
things
even
that the main
smaller.
surveyor did. Sorry, go on.
The refraction will make the numbers smaller. The problem is they're too big.
So the main thing that the main surveyor did for the zenith angle calculations is he did all of his observations at altitude to minimize refraction. And what we would see on a standard day, unless there are really weird conditions, is the only thing that would actually do, it would help flatten the Earth, not make it look curved. So
All
it's
right, well,
actually an error bar in his favor because it's more conservative rather than an error bar that's giving a larger standard deviation.
All right, let
or
me ask
standard
this.
Deviation from the mean, should I say.
Media. That's all I got to say.
Let me ask this: if you had a light source like an object, so you take the readings there, and then you have the place you're viewing it from, and you take the readings there, right? Is that what the main surveyor did?
I don't know.
Well, does
Yes.
anyone know?
Essentially.
I
He
phoned
pointed
up
at two different
a,
points, yes.
detecting
That's what he did.
survey.
Okay.
They don't take in.
So does light
They don't take in curvature at all. They don't. They don't take in any curvature. They said they wouldn't waste their time with it. Only an idiot would be doing that.
Yeah, that's because you're talking to guys doing level 1 type surveying, which is normally done over fairly short periods to build things like houses
These guys are
and
doing it on
buildings and that kind of stuff.
motorways, roads.
Yeah,
and,
motorways, short
and
distance
streets.
surveying.
Street surveying.
Streets are
That's what they
short
were doing.
distance surveying. You don't need to do long distance surveying
Well, they
for
were
that.
doing long
So when you're
motorways as
you're talking about things like geodetic surveying or building big long bridges, then they take that shit into account.
No curvature was
So there are
taken.
3
What
basic
about
levels
the
of
Chinese
surveying:
one?
level 1, 2, and 3.
Trust,
And it's
the
the third level you do that.
doing a bridge, they do not account for curvature. It is built in sections.
Yep. There you go.
Okay, real quick though, if you have these 2 measurements of the temperature, pressure, and humidity. Now, so if you're going into the one with
Sorry, Jeremy, I just want to rebut that bridge thing. Yeah, I'd agree generally if you're doing that, but if you're building a suspension bridge, then the thing you're actually concerned about is the angles of the towers that provide the suspension for the bridge. That's the bit they're concerned about, and that's the bit they involve curvature in. Sorry, Jeremy, carry on.
It'd be just like you did
Elevation also, Jeremy.
to the wherever it's
Temperature, humidity, elevation.
for as well.
Go take angle measurements to any suspension bridge, and that thing is moving 8 to 10 inches, depending on the height of the structure. You can't take an accurate measurement on something that's moving. You can only take mean averages, and then good luck doing that. You want to say
Right,
that?
you have to have the elevation too.
Yeah, you're
That matters too, Jeremy.
But they plan it into the way they build it. And,
Sure they do.
and it's part of the documentation, and I've seen it multiple times, so I'm happy with that.
Yeah, of course you are.
Yeah, because that's what surveyors do. And when I need an expert, because I don't know enough on a topic, I go and speak to an expert. And I go, wow, unless you give me a good reason to sort of doubt what you're saying, then I'm probably going to believe you. So if I went to Jin and asked him about that, and I went to his proper surveyor, and we start talking about building suspension bridges, I'm probably going to go with the guy that fucking does it.
All right.
Again,
If you go to
so
that same
I've
surveyor
actually
and ask him
I've
how
always gone over
accurate his
I've gone
measurement
over
is on a
blueprints
moving
and
bridge.
the designs of those suspension bridges. Again, they're built in sections, and the tension of the bridge is more efficient to, or is more important to them than the curvature. They don't account for curvature when building a suspension bridge. It's the amount of tension and weight that's going to be put on that bridge, and each section has where it's
Whoa, what did you
All
just
right.
say?
Let me know when you guys are done so I can get 5 minutes.
The bridge is built in flat sections. They can't account for curvature. They have to build flat
not
pieces
flat.
and put them together.
Again,
5 minutes, Jeremy, in this room? Are you kidding
Lemon,
me?
it's not
Like
flat
two-
either.
I don't
It's
know,
not
2
flat either.
minutes, 3
Each
minutes,
section needs to be
maybe?
drained.
Hold on, Sean. Jeremy wants to get 30 minutes. Go ahead, Jeremy. Take your 45 minutes.
45 minutes. Good looking.
Fuck with you,
So
man.
if you're making a horizontal line and you have temperature, pressure, and humidity readings at both points, where the light's coming from and where you're viewing the light. So if you go into a less dense medium, is the light going to bend up or down?
You have to have elevation
It's the
too,
same
Jeremy.
elevation. It's a horizontal line.
All the same. No, I mean elevation where you're doing your shit to begin with.
What?
Where are you at? Around sea level? Above? Below? You 1,000 miles above? You 2 miles below? I mean, where you at?
I don't think he's liking your
That
question.
don't matter.
I don't
Well, if
know.
you're talking about temperature and humidity and pressure, you have to talk about elevation because that differentiates all of that. What the hell are you guys talking about?
Let's listen.
Sea level, below sea level, 1,000 miles above sea level. There's no difference. What do you guys mean?
No, in terms of relative pressure and temperature, I don't think there'd be much difference.
Yeah, they're relative to each other. I don't think you might have more. Listen, I don't know, but if you're at
Go
point
ahead.
looking
Go
at the
ahead.
light,
Never mind. Go ahead.
yeah, if you're at the point looking at the light where you have your one pressure reading and say the pressure's lower and the humidity and the temperature is lower, and then the place where the light's coming from, the object, is all higher, which way is the light going to bend?
Depends. Are you higher than it? Same elevation?
It's a horizontal
Is it
line.
lower than you?
Horizontal line, same height.
Yeah, on a standard day, it's going to lift the object up slightly.
So what's your question
No,
about
so the
straight
light's
lines?
gonna.
So the light's effectively bending slightly down.
So the light's bending down. So from the reverse angle, the light would be bending up.
No.
So if you're from a lower pressure, temperature, and humidity, and you look at the thing, the light bends down. But then if you're at that place and you look into the lower one, it bends down again.
So think about it. If I'm pointing at something above your head, like I'm pointing at something above your head, but somehow
I'm drawing it out on my whiteboard.
Yeah, draw it on your whiteboard, but draw two people. One person is pointing something above somebody's head. It's gonna go. It's actually gonna appear in that person's eye, so it's got to go up and then down. Okay, and so for that same line to be doing to go back to the other person, it's gonna be doing the exact same thing in the other direction.
Yeah, hold on a second. So if light goes from low pressure to high pressure, it bends down. And if it goes from high pressure, what's up?
No.
You said no?
Bends toward the
No.
thicker medium.
No, it depends on the angle.
It's fucking horizontal.
Then it will not bend.
That's a question that's not you don't have to tell them the exceptions.
Curve and an angle or a line are different things. Like, is it making a curve bend or is it making a line bend?
Good question. I don't know. Hold on.
Guys, this is all happening on a horizontal plane, same elevation and everything. So
Nothing will
let's get
happen.
past that.
Nothing will happen.
It makes a line bend. That
No.
is what a refraction does.
No, it won't.
Is there anyone here that actually knows this
Yeah,
stuff?
yeah, dude. That's why I'm waiting for you to your question. You still have the same question?
You said nothing would happen. For some reason
Nothing would happen. You look at the aquarium from above, nothing happened. You look from the side, then something happened.
Yeah. But what refraction does it? If you had a straight line, in vacuum, and you put it in a refractive medium, you would see it bend relative to that straight.
Yeah, that's why it's a
So if
problem
you're
to
ma-
try and stipulate
if you're
a
ma-
horizontal line as in straight and try and factor in refraction.
Yeah.
So if you're making a horizontal line and you have the pressure, temperature, humidity readings at one point, and then all those readings at the other point you're viewing it from, and you make a horizontal line, nothing would happen.
The horizontal
No.
line.
Okay, Jeremy, sorry, I wasn't paying attention earlier. What's your question?
Well, I'm wondering what happens when light goes from a low pressure to a high pressure at a horizontal angle, at no angle, at a horizontal line.
From low pressure to high pressure, it'll start to refract less, depending on which way it's coming in from.
It's horizontal.
So, either way, if it's coming in from the top, okay, if it's a horizontal, and it's is it going into a different medium, like where?
Yeah, it's going from low pressure to high pressure.
I know, but where it was propagated from, was it a higher pressure and then it's going to lower pressure and then higher pressure, or
We have
always...
two people. We can see two people. We have light going from low pressure to high pressure.
Okay, so you're saying that, like, basically at where the person is, the second person is, it's just higher pressure. It's not kind of equal layers.
We only have two readings. I really want a baller to answer this.
I know.
Offense,
It's like
but
now we have to explain the question to somebody who has listened to the question to begin with. But
we have two. We have my bad. We have two measurement readings. One from where both observers have two pressure readings. One of them's high pressure. One of them's low pressure. They're making a horizontal line. Which way does the light bend? What's up now?
So it's a horizontal line.
That's the thing, is you keep saying
yeah,
horizontal
there's no-
line,
yeah.
that gives no angle for it to bend from or
so
to.
it depends on
So what is your question, Jeremy? Because you're not asking it correctly.
you have to understand the boundary between the two densities, or the density difference. Like, let's say it's two people and they're not far away enough for
What the hell, Jeremy? Your voice has changed.
What am I saying? The boundary between the two places, the two densities or whatever. If it's 90 degrees or if it's a parallel, so if it's parallel or perpendicular with that boundary, then you're not going to really experience refraction. It has to come in at some angle in between 0 and 90 degrees.
But the thing is, Kosho, it will, it's obviously what you're seeing isn't necessarily what's actually there, right? Because there's refraction. So if you're looking at it straight on, doesn't mean that the light is coming in straight on, right?
So
the light
if
would be
it's-
reflecting due to a different medium.
Hold on, percent. So it's if we have a, you guys say there's no refraction from top to bottom, from 90 degrees up.
When you put a
Right?
stipulation of
Hold
a
on,
horizontal
just
line.
let me just lead you guys
That's-
with like 5 questions real quick. There's no refraction from up to down, right? 90 degrees.
Right.
And it's going from all different temperature and pressure gradients and humidity, but there's no refraction because it's 90 degrees.
Yep.
If the boundary and the direction the light's coming from is 90 degrees perpendicular, there'd be zero refraction.
Okay, so what makes that different when you're looking horizontally?
Because your angle of incidence has changed. And your angle of incidence is equal to the angle of your exit. And when you're coming in at 90 degrees, you're coming out at 90 degrees. When you're coming in at a 45-degree angle, then all of a sudden that angle is going to divert down by 45 degrees.
That's not necessarily correct.
I know, but it's easy. I'm going simple percentage. Come on.
Yeah, but to be honest, there shouldn't be much of a difference.
It's basic.
Well, I don't understand the horizontal to vertical difference. What's
I know,
the
Jeremy. There's if it's at those extreme angles, at those exact angles, it's gonna be no refraction. Okay, if it's almost perpendicular, or if it's perpendicular or almost perpendicular, it's gonna be less and less. It's gonna get more and more and more as it gets more and more towards being parallel with the incidence angle, or with the boundary angle.
Easy way to visualize that is the classic glass of water and a pencil, and you can show it really.
That's with
really
a curved
simply.
glass, though. When you use a straight piece of glass, does that even
Oh,
happen?
come on, Jerry. We're just going for an analogy here.
I know. Does that
You
happen?
still don't get a
Straight
curved
piece of
look.
glass or no?
It still is just a straight angle of light. It's not a curve.
I don't understand why the horizontal angles matters to the vertical if we're just going from one pressure gradient to another. That's what happens. Same thing that happens vertically.
If you're assuming that the light is passing through perfectly through the like center of the molecule, and every molecule is passing like perfectly symmetrically, then there would be no effect whether it's vertical or horizontal. But we know that these lights are passing through these molecules, like the molecules are random and you know everywhere. So the light would be passing through some molecules at an angle, and there would be refraction. You could claim that the chances of it refracting in any one direction is the same, and averaging it out, there would be, you know, it would go straight down. But that's not the same as it actually going straight down. You know,
you're not saying anything.
Oh God, this is the vacuum chamber argument with the light.
Exactly,
again.
it is. It's just another one of those.
Jeremy's
Hold on a second. Hold on. Hold on a second. Hold on. So if I have a let's say I have a tube that I can see through, and it's all the same temperature, pressure, and humidity throughout the whole thing, right? And I look up with it, there'll be no refraction. But now I look, and I'm only looking from the beginning of the tube to the end of the tube, right?
There'd be no refraction anywhere in it.
There'd be no refraction. Okay. What if in this tube? All right. What if in this tube I had a high pressure at one end, a low pressure at the other end of the tube, and I'm still only looking from the ends of the tubes. If I look up, there won't be any refraction. But if I turn the tube sideways, there'll be refraction.
No, there's refraction regardless, man.
Depends if the light beam that you're firing changes medium. If it does, there is refraction. If it doesn't, there isn't.
That's not true because it changes refraction when it changes. There's no refraction, you guys claim, at 90 degrees.
It's perfectly.
It's changing mediums.
Yeah, it's close to zero.
Yeah.
Do you see
There is refraction at 90 degrees. They're wrong about
Chaiki's image?
I know, but this
don't
is
listen
what they
to
say.
Do you see Chaiki's image? Chaiki has an image. If it were coming at an angle that was directly straight across that barrier, that would be 90 degrees. There'd be no refraction. The refraction increases as that angle becomes more and more close to being parallel with that line. If it's parallel with that line, then it's not going through a difference in mediums. So you're not going to expect refraction that way either.
Yeah, but by that logic, if it's
is as an angle between those two being the least and the most.
But by that logic, Kosho, at a perfectly horizontal line would go through the same layer of atmosphere, and so it shouldn't have any refraction.
Yeah, by that logic. It's not even by that logic. That's exactly what I stated.
Well, that's
what
wrong,
happened.
though, Kosho.
Essentially, it's
No,
true. But
it absolutely does
every
for
object you look at has
perfectly horizontal ones. Now, we don't actually observe perfectly horizontal. We observe some small angle of incidence, and that's where we get the visualization of refraction.
Yeah, the important thing is you can't just assume that the medium is
I drew
one-
something out on my board. I'm taking a picture.
That's why I don't actually think that what Jeremy is asking is the words he's using about the perfectly horizontal. So what is it, Jeremy?
He's saying your line of sight is perfectly horizontal. Are the wave, like the rays of light that are reflecting off the thing into your retina, going to be perfectly horizontal? No.
Okay, there's what I drew out on my. There's what I drew out on my board. We've got two people. One's on the ground. One's in the air. They're looking at each other. One's at low pressure. One's at high pressure. But they're 90 degrees, so there's no refraction, right?
Right. You're only talking about the
Okay.
photon. You're only
Okay,
talking
hold
about-
on.
Hold on.
Let me just.
1 second.
Go ahead.
You're only talking about the one photon coming off of his eyeball.
Still, yeah, because I mean,
Guys, there's a reason why mirages exist. It's because your line of sight does not match what what actually is there. The apparent location isn't necessarily the actual location.
Drawing's already gone. But yeah, Jeremy, that's true. That's the
Okay,
least
we're
amount.
looking 90 degrees.
Yeah.
There's no 90 degrees, low pressure to high pressure, no refraction. All of a sudden, we turn that line horizontal, and there's refraction from low pressure to high pressure.
Well,
Why?
from the minimum refraction to the maximum refraction.
Why is there maximum refraction if it's low pressure and high pressure in both places?
Because the
Why
angle of
does the
incidence
horizontal?
is the most extreme. Yeah.
There's no angle. It's straight on, straight ahead.
Yeah, if it was perfectly straight, there'd be absolutely none.
Straight angle. Yes, I said this. We're making a horizontal line.
Yeah, well, it depends on how far away you are because of the curve of the Earth. Because the Earth's curved, even a horizontal line.
No, this measurement is.
Yeah.
No, can I jump in? Right. There's nothing about the Earth's curve that makes the light refract if it goes horizontal.
Because
the light would curve regardless, as long as there is a gradient. So let's say that the gradient goes perfectly vertically, like just in the case where Jeremy explaining, right? We have a perfect vertical gradient, and then you shoot the laser or this perfect ray of light horizontally. It is going to bend the most that it can do. So that's the direction where there's the maximum refraction.
Yeah, but in a flat Earth, if it was the gradient was like it is on Earth, like it's the lowest or highest pressure to lowest and densities and all that stuff, then you're shooting it horizontally. You're not changing mediums.
I am suspecting that
what
this
I'm-
is
what I'm
another
saying-
pedantic argument, and Jeremy is imagining very idealized situation. And Fug, can you post the link to the derivation of refraction formulas which you are talking about right now? That would help.
Okay,
I
in
don't
my
have
in my
it, but
example,
you can go from the differential form of Snell's law, or you can use any other equation that applies to a gradient.
all right, guys, in the picture on my whiteboard, nothing changes. It's high pressure. You're looking to low pressure straight on. We could do this in a tube, and the people wouldn't even know they had tilted horizontally.
Did you get permission to use someone else's whiteboard, Jeremy?
That's my whiteboard. If we do this in a tube, okay, we pretend these people on my whiteboard are in a fucking tube. Okay, they're in a tube. They don't even know which way they're orientated. We're in space. You guys will love this. We're in outer space. All right, these people are in a tube. It's low pressure. No, well, they're in a concealed container tube. They got low pressure on one side on one end and high pressure on one end, and they can see each other. Now you're telling me if I know a perfectly straight line between the two of them, you're telling me for some reason, if I tilt this tube horizontally, there's
No, in space there'd be no gradient, man. So you have to bring
inside
it
the
back to
tube. Inside the tube, there's the gradient, the same gradient.
Gradient.
I have to bring it back to Earth. Just bring it back to Earth. It's fine. In the
Okay.
tube on Earth.
Pretend
I'd
I'm
like
in
to
Earth.
say
Pretend
hi to
I'm on
Coach
Earth.
Show.
Pretend I'm on Earth, and we took these people. They're in a tube. They're looking up, high pressure, low pressure. We're going to freeze frame it, tilt them 90 degrees horizontal, still looking at each other in a straight line. High pressure, low pressure, same exact temperature, pressure, humidity, all that. For some reason, now there's a gradient because we tilted them sideways.
But in your question, you're saying that you're essentially freezing the atmosphere that's in there, right?
Yeah, I'm
You're
taking
saying
the
that
same low
gradient
pressure.
He didn't mean freeze it. He meant like
doesn't change
people's positions. Yeah.
Right. We can
Well,
do
I mean, is there
Take the same
you're saying that
exact
there's still
medium
a
you're
pressure
looking.
difference.
Here's what I'm saying. Take the same exact medium you're looking through, right? You're looking through the same medium, low pressure to high pressure, up and down, no refraction. All of a sudden, I look low pressure to high pressure horizontally, still a straight line, and there's somehow how does refraction come into it then?
I think.
Well, I'm saying that if you're tilting the tube, you won't have low pressure on one end and high pressure on the other, because the gradient is going to distribute vertically.
Jeremy, I completely understand your hypothetical question, and I think what's being missed is the boundary between low and high pressure. If that boundary is vertical when you're looking horizontal, that'll give you a perpendicular angle for the light through the medium, so there's going to be no refraction. When you start to have a varying, it's not a boundary where this is low, I move 2 inches, this is high. I'm not saying that. What I'm saying in this perfect hypothetical, that's essentially what's happening. And when you have a varying transition from low to high and it's not perfectly vertical, that's when you're going to have the refraction. This is why when you look straight up, and we use that example, it is because the, I don't want to call it layers, but the different pressures as you increase in elevation are consistent, where you're not going to have that refraction looking straight up. But you can't have that perfect, layering effect when you look horizontal. But in your hypothetical, then yes.
So what would we need in the horizontal thing? What other measurements would we need to know where the gradient is? Would we need measurements in between?
I would imagine you would, to be extremely accurate, yes.
If you needed to be real, like say you were measuring something where like plumb lines weren't level and you needed to be extremely accurate. Yeah, something like that.
Sure. Every 50 feet, take a reading.
50 feet, you think's good?
depending on your distance. If you're measuring 100 feet, maybe do every 10 feet. If you're doing a mile, measure every 400 feet.
If you were trying to be super accurate and measure, say you were trying to measure if a horizontal line was just fractions of seconds, not even, or I don't know what was it, six seconds?
You're right. If it's almost like measuring miles. You can be kind of accurate with just a mile, whole number, but if you measure in inches, you're going to be extremely accurate. So this is the same thing. So depending on your whatever your minimized distance is, every 50 feet for a mile, you're going to be extremely accurate. Every 100 feet for a mile, you're going to be less accurate, but pretty accurate.
My point is, if you just had the point, like in my picture that on my whiteboard, and you're looking horizontal and you just have low pressure one spot, high pressure where you're viewing it from, what does that tell you? Does that tell you anything?
I know what you're trying to do. It's not.
Hold on, let this guy finish. Does that tell you anything? Who is that, BioDuel? Does that tell you anything?
It tells me kind of what's going on, but I wouldn't be able to make an accurate prediction of.
You wouldn't be able to tell which way the light was bending or anything off of this, would you?
I don't think so, no.
Yeah, all right. There's the main surveyor's parallel plumb lines are debunked. Right
they
there.
haven't been debunked, and you're
No,
boom.
my incredulity doesn't disprove anything. That's my opinion, and I'm not experienced.
Well, I think
if we didn't have those measurements, would we be able to tell what way the light's bending?
Yes, I wouldn't be able to.
No, nobody would be able to, right? Correct. You're correct.
Well, I tried to point this out earlier, and it's a common misconception. From what I heard, I think BioDuel also repeated this, that if you're shooting a ray of light, what you say, along the gradient, like horizontally, then the common misconception is that there will be no refraction, and that's incorrect. Like this is repeated too many times. And so when flat earthers start to look into how refraction works, they will find out that this isn't the case. It relies on an incorrect understanding of what Snell's law is describing. So that's my only comment here, right? A horizontal ray of light will curve, will refract.
Ultimately, what does it describe? The fact that light beam traveling through a medium is interacting with every atom it hits, and it doesn't go straight after every atom it hits.
Well, according to what you just said, there'd be vertical refraction. They say there's not.
No, vertical is different, right? So there's a difference between vertical and horizontal. In vertical,
I was talking about what the other guy just said. Sorry, the other guy just said.
All right.
There's a
I think that happens simply due to probabilities, Jeremy.
BioDuel just debunked the main surveyor's plumb lines are parallel. Thanks, BioDuel.
My incredulity doesn't do anything, Jeremy. Don't
Thanks, BioDuel. Good looking.
You have to lie
That
to
wouldn't,
get your
those
point across.
measurements wouldn't tell you nothing,
So,
right,
Jeremy, you have
BioDuel?
to lie to get your point across?
BioDuel, would those measurements tell you
Good
anything
looking,
about which way?
man.
BioDuel, would those measurements tell you anything about which way light's bending?
They wouldn't tell me anything in particular. I can make an educated guess.
Why? Why would you make a guess? Maybe it's not refracting. How do you know?
I can make an educated guess as to what would happen, but I wouldn't
how?
be able to put my name
Okay,
on
what's
it.
your guess based on?
My guess would just be with what I know about light traveling through different mediums at different densities, but I wouldn't be able to make an accurate prediction in reality.
Jeremy,
Talking about reality, so thanks for playing.
Jeremy, can you list the measurements that you know hypothetically would give for this? Like what are the parameters that are measured?
What are the main surveyor's measurements that he took?
I don't know, just the one you would present us. Either it's from him, I don't know, but like, is it temperature, pressure? What is it?
He has temperature, pressure, humidity readings at 2 points.
Way different than just
which
saying.
BioDuel just let us know that wouldn't tell us anything about which way the light's bending. So
And those 2 points are from the place where the light is coming from and the place where the light is ending up.
Yep.
Oh yeah, that wouldn't be enough. You would need to have.
That's not enough. I know. I thank
the
you very
vertical
much.
gradient.
Thank you.
You would need
I've
to have
been
the vertical
arguing with
gradient.
people over this. I've been arguing with people over this for months. I'm glad you guys.
Here, Jeremy, what you're doing is
measurements are now worthless. Thank you.
Jeremy, what you're essentially saying is, if I present to you a diagram and say, build my house high because my neighbor's house is low, could you build me a house? No. But if you give me, or if I gave you the variables, then you would be able to build this house. That's what you did to me, is by saying low to high without giving values when you knew the values pertaining to this.
Can
you
I?
know the
Can I?
values and you're using low and high.
Sorry, what?
Totally different.
What?
Can I? Can I, Jeremy? Can I tell you what you could do with those values?
Could you tell which way the light's bending with just those values?
Like with anything, you could make some assumptions, like that the atmosphere is
Why-
normal. Like,
Why
for
are we
instance,
making
that
assumptions? No, we're
Well-
talking about measurements. We're not making
Well-
assumptions. We're just talking about measurements.
Gradient.
Well,
I know
Jeremy,
you want to
Jeremy,
save these.
Jeremy, you're,
I know you desperately want to save these guys,
hang on, Jeremy.
but it's okay, bro. Tell
Hang
the
on,
truth.
Jeremy. Hang on, Jeremy. I addressed your first question. I think I was pretty honest about it. But what
You
you
were.
can do with any model that you're using, you have assumptions, and so you're asking us by applying whatever model you have, what result can you get? So because there are no models without assumptions, you are essentially asking us for what models and their assumptions can you use to tell us which way the light goes. So one assumption you could make is that the pressure decreases with altitude, that the temperature decreases with altitude, as in a normal atmosphere. Now you don't
We're
have
making a
those
horizontal
measurements.
line. There's no we're
Now,
making a
you don't have
horizontal
those
line.
measurements, but
Hold on. We're
that can
making
be
a
a
horizontal
reasonable
line. There's no
approximation.
altitude change. We're making a
No,
horizontal
you
line.
make it. You make it. No one make
We're
it.
making a horizontal line. There's no
But
altitude change.
is that what he did?
Yes, he made a horizontal line. Shut. If
You
you don't know what we're
sure?
talking
You sure?
about,
Yeah,
just
I don't know. You know why, Jeremy? Because you didn't present it.
it's the main
Yeah,
surveyor.
It's
again,
the main
Jeremy,
surveyor. Thank you.
Hold on,
Please
Jackie.
don't
I'm
Hold
not
on,
going
hold on.
to,
this guy.
look for it.
Jeremy,
Let him have a
in
conversation
this
with
case,
Fox real quick.
yeah, sorry. Yeah, Jeremy, in this case, it's not the gradient along the direction of travel; it's the vertical gradient at each point. So what I mean when the pressure is decreasing with altitude is exactly that. I don't mean that the pressure is decreasing along the ray of light. I'm saying the pressure decreases as you go up. Like those assumptions you can make, and that
Okay,
that
the
is one
pressure
way
decreases
to,
as you
to
listen.
model the atmosphere.
Listen to me. The pressure decreases as you go up. We're making a horizontal line. So would that mean we're at the same pressure the whole time?
No, I'm saying that in the model of my understanding of refraction and how light behaves, which is what you're asking me about, then the vertical gradient is relevant.
Yes, but we're making a horizontal line, so it's staying. If the pressure decreases as you go up, since we're staying at the same level of height, the same pressure, right? How much refraction do you get off of that?
No, you're misapplying the model if you do it that way. Right?
Well-
If you don't really want me to give answers according to the model I have, then, I mean, ask someone else. But I'm going to give answers according to
No, I
my
mean,
understanding
you're
of the model.
you're telling me as we go up, you have to take this into account that as you go up, the pressure changes. We're not going up; we're staying at the same height. So if there's no pressure change, are we going to have refraction?
Yeah,
Can I-
that's why I'm taking it into account. That's why I'm saying that's an important parameter, because it does affect it. That's
If
what I
there's
said
no
from the
pressure
beginning,
change-
that it's the vertical the vertical change in pressure and temperature is what affects the bending of the light.
Yes, but we're not. If we're staying at the then if it changes as you go vertical, and we're staying at the same height, what does that have to do with it changing refraction? Since then it's not changing pressure.
Jeremy,
That's our
Thank
that's
you.
our
Please
understanding
let
of
this
how
guy
refraction
talk.
works.
Hold on. What's your
I
name?
want
What's
the
your name, guy?
data, Jeremy. While
What's
he's
your
still
name?
providing
What's this guy's
data.
name?
Jackie, please stop for a second.
What's this
No, I
guy's
want
name
the
right now?
data.
What's this guy's name I'm talking to?
Fuck.
What's his name? Fuck.
Fugix. We
I'm
call him
at the
Fugix.
bottom of the list.
Fugix.
Yeah.
I've been calling him fuck this whole time.
It's fine.
What do you want to be called? Fuck or Fugix?
Fugix.
All right. That's probably more appropriate. So if we're going through a medium and there's no refraction change, there's no pressure change, is there refraction?
Yes, that's what I'm saying, and that's the common misconception. That the common misconception is that if you travel along the same pressure and temperature and all of that, that there will be no refraction. That's wrong. That's a misconception.
So which way does the light bend when there's no pressure change?
When there's no
temperature,
as
pressure,
long-
or humidity
as long as
change, which
there
way
is
does
a-
light bend?
Yeah, as long as there's a difference across.
No, there's
the
no
direct-
difference.
Hang on.
There's no
Hang
difference.
on. Let me
my
let me
bad.
answer.
My
As
bad,
long
you're
as
right,
there
go
is a
ahead.
difference across the direction you're traveling, in pressure, temperature, all of those factors that affect the refractive index, there's going to be a bending towards the side that is more optically dense.
I think I found the paper where these formulas are derived, and that's what Fugix is talking about. The paper is in the chat.
Okay, so here we are, Fugix. We're going from low pressure to high pressure. Which way does it bend?
Are you saying that the ray is pointing upwards, for example, in the atmosphere?
Straight line, bro.
Yes, but
Up,
that's the example,
sideways,
upwards, yes? For example, upwards?
whatever. Straight line, the temperature, pressure, and humidity are different at both spots. Which way does the light bend, from high to low or low to high? Will it go up or down if you're going from low to high, or what?
Well, if those are the only assumptions that you make, if you don't know about any other gradients, then it doesn't bend.
Okay, thank you.
So what I'm saying is, it's the gradient across the direction of travel that is what determines whether it bends or not. So you need to have an idea of that, either by measurement or by knowing what the vertical direction is on those points that you're measuring from and to.
So
but
in
you
order
still
to
know
be sure
what's vertical.
You're saying in order to be sure you would need measurements in between.
Not
Otherwise,
in
you're
between.
just otherwise
Not
you're
in
just
between,
guessing.
because not in between. As I said, you would either have to make reasonable assumption about the vertical.
No, we're not making
gradient
assumptions.
of the
We're doing
pressure or
measurements.
temperature.
Guy, when I measure a
you would
2
have
by
to
4,
either do that. You have to
When I-
either do that or measure it.
when I measure a 2 by 4, I don't make no assumptions about how long an inch is or anything like that. I just put the tape measure down to it.
What you're saying, though, is that a 2 by 4 is long. You're not giving any numbers or measurements. You're just saying this is long. This piece of wood is long.
Yeah, but
Yes, that's what
You're-
we're doing
you're
when
not-
we're making these measurements of plumb lines not being parallel. We're
Yeah,
taking a measurement
again,
of length.
you're not measuring the whole 2 by 4. You're choosing one point and one at each end of the 2 by 4, and you're measuring the distance between those 2 points. Right? You're not making a 3D measurement of any kind. You're summarizing the entire existence of that 2 by 4
Okay,
into
so-
a number.
All right.
So you're making assumptions, and that's fine.
Okay, so if we have the temperature, pressure, and humidity range from both 2 spots, you'd be able to tell which way the light was bending. You're telling me?
I said by either making an assumption about the vertical gradient or by measuring the vertical gradients, you can get an answer for that. If you make an assumption, just assume it's a standard atmosphere, then I think for most cases it would bend down.
Well, all we know is at one point it's low pressure and one temperature and one humidity. At another point, it's a little different. That's all you know in this.
Well, it's not all I know. I mean, it's
No, for this measure, we're doing a measurement.
You
Hold on.
can, for example, say something about what time of day it was measured, whether it's late at night, whether it's close to the surface. All of those affect whether or not whether or not a normal atmosphere is a reasonable assumption. Right. Sure, there are cases where
So you're just making assumptions, and this wouldn't be clear cut. It could be way different than what you would assume.
In your hypothetical, it's missing a lot of information. That's the problem.
Could it be way different than you're assuming, or no?
Possibly, yes, of course.
The total opposite.
It's important that you understand
it's
what you're
Save
doing.
him, Kosho. Save him.
I'm trying to.
Well, I mean,
no, Fugitive.
Yeah,
He's building a weapon against plane surveyor.
Yeah, I get it. But I mean, it shouldn't matter if it's.
He's being very disingenuous.
As long as I get to give my full answer, then it's up to him if he wants to misuse it.
Very decided to misuse it.
You think I'm being disingenuous?
I
said that.
Motherfucker.
Biodual, you admitted we needed more measurements. I agree with you. It's not disingenuous.
Well, Biodual,
Well,
do you
what
know?
you're doing right now, you're not trying to learn from him. You're just trying to gain
What
Do you
more
know-
measurements? Can we get the measurements we already have?
Biodual, if you
What
know,
measurements do you want? I tried to give them to give me the measurements. They wouldn't do it. I don't know. Maybe they posted them in the chat. I haven't been listening.
So you don't know if there was change in elevation, if it was a horizontal line. You don't know nothing. You just assume that if it was an horizontal line, what would happen?
I mean, he said he made a horizontal line. If you don't think so, then whatever. I don't.
Well, I don't know what he. Let me see what he said.
It's when the main surveyor debated Witzik. Go look it up.
Thank you. Go look it up.
We've been over this for days.
I'm not going to look up anything.
He never
I don't
said
care,
anything
then don't look it up. I
online.
don't care.
If you present something, then present it.
I didn't present this. You guys presented this. The main surveyor presented this. Go ask him for the shit.
Is he here? I didn't hear him present this.
He presented this to Witsit one night on YouTube.
Alex, I don't believe you.
Jeremy, he never said he made a horizontal line. Never. You're imagining it.
He distinctly said you don't need to do it horizontally.
He wasn't making a horizontal line?
He didn't even need to know the altitude of the two measurements.
Absolutely not.
He wasn't measuring if plumb lines were parallel?
Nope. Yes, he was. Has nothing to do with the horizontal line, though.
So what line did he
Why
measure?
don't you go back and watch it again? Because apparently you don't understand.
What line did he
He
measure?
didn't measure any line, just angles. He measured angles. That's it.
An awful lot
What's
of
the name of this guy who measured it?
understand what's being done.
What's the name of the guy who measured?
Wasn't he trying to measure a 180-degree angle? A straight line to the other plumb line?
The main
He
surveyor.
was. He was, yes. That's
The
true.
main surveyor.
Okay, so there we go. He's making a horizontal line.
Doesn't need a horizontal line for that, though.
To make a straight line?
No, he does not need a. He does not need a horizontal line. He considered it a straight line. Yes.
Can you? Because I didn't see this. Could you briefly describe how he was establishing the angles between the plumb lines? Do you recall?
Yeah, I'm
gonna have to go back.
drawing a graphic of that right now that I'm going to use, but it's going to be another 10 minutes.
Well, I hadn't seen that. I hadn't seen that debate, and it sounds interesting. I'm just curious how that works.
I have to go get X-rays and shit, but I think someone was trying to ask me a question. I don't want to be accused of dodging, so before I go, if there's still a question.
Yeah, biodual. Let's say we weren't making a horizontal line and it was a 45-degree line, and those were the numbers we had. Same numbers, one spot and another spot. Would you be able to tell anything, or would you need measurements in between?
I would need the exact numbers. You telling me high and low doesn't tell me anything.
Just different temperature, pressure, and humidity readings at both spots. And we're making a...
Again, different doesn't tell me anything.
No, Kojo, if you don't have to watch the Witsit main surveyor thing, because it's literally just Witsit being his usual dishonest, over-talking idiot, and surveyor trying to answer in time. That cluster.
I plan to watch it. I'm anticipating Scott Mackey's explanation, and that would suffice. There's no reason for me to watch it.
Yeah, let's see. I thought he was making a straight line to both the plumb lines, and it was it wasn't the right angle. A horizontal line, and the horizontal line was off by X amount of degrees.
You never watched it.
No, he make reciprocal angles, and they never horizontal.
What, Jeremy?
Hey, Jeremy, why don't you fire off a memo to the Geodetic Surveyors Association to inform them of the existence of refraction? They're apparently unaware of this, Jeremy.
Well, I'm sure they've been measuring their optical corridor real good. No?
Yeah, teach them all about it, Jeremy.
Yeah. Oh, wait, yeah, that is a bad idea. You have to probably understand, Jeremy, that these guys, I mean, I don't, like, I just understand that you're trying to come here to find flaws in our understanding, I suppose. But the people who do this, geodesic surveyors, they have more expertise than any of us in this, and they're gonna know what they're doing. You know what I mean? But they're gonna know if they're doing something that has no reason to work, or has a completely flawed analysis, or whatever. But I know what you're doing right now, man, and I'm not gonna get in your way.
Yeah, I mean, you guys think you got measurements of plumb lines being parallel, but you just got measurements at 2 points. How do you know what happened? How do you know what happened in the middle? What if something happened in the middle?
Well,
and
explosion or something?
What do you think happened in the middle?
I don't know.
Cookie
Maybe
action in the middle.
maybe
have
a
no
bird.
clue, man.
Maybe a bird farted in the middle. Who knows?
Okay.
That's
And then how long would that affect it? Would one bird fart? How much would that affect?
Oh, how long did he look and check the measurements?
Just describe that.
What if the same bird kept farting in the middle?
Oh, did you see a bird farting, or did you see a bird there where it could have been farting?
What if Jeremy just kept farting in voice chat?
Not right now.
So this bird fart, we talking European or African swallow?
Emu.
Well, I mean, African swallows are non-migratory, but
Jeremy, I think what you're questioning is not what's happening, but the precision of what.
no. My question is, what's happening in the middle when we have no idea because those measurements aren't there?
That's what I'm saying.
That's my question specifically.
This is basically my argument that I had with like against fight the flat Earth. Told them that
Dude, fight the flat Earth
only
is
have
a
the two
clown who
measurements.
gets these random Twitter people to go on there, flat earthers we never heard of. Now, I'm not saying you or Chemo, but sometimes we will have like some legit flat earthers on there. You gave him a run for his money. I only watched the first part of it with you and him, but
Nice save, Jeremy.
you were doing good at the start. No, I'm saying most of the flat earthers fight the flat earth
I say
has
almost
are trash. They're
Probably.
straight hot
Flat
garbage.
earthers are trash.
Because the reason
Not
why
the good ones up in here.
Not Chemo, but 100%.
Not percentage. If it
Flat
wasn't for Witsit, if
You
it
know
wasn't
who
for
I've
Witsit,
seen recently?
percentage-
I've seen I saw this one thing by David Weiss versus some like woman that was just straight garbage. She's like a criminal defense attorney, but she was actually like one of the dumbest people I've seen for a while. But David Weiss, he's one of the best. Like he's my favorite flat earther.
This
right
is
now.
not a troll. 100%. No doubt about it. I would give $1 million and bet against $1. There's no reason for anybody to ever say that David Weiss is one of the best flat earthers, man.
Dude, did you see the debate he had against? I think her name was Tanis or something like that.
Okay, Edgar.
Dr. Terry,
Okay, we believe you, Edgar.
Someone linked to it in this like server yesterday or something, and that's how I even knew about it. And he
Sure,
just
Edgar.
dominated this woman, straight up dominated her.
All
Even
right.
with like
I'll
the
check it out.
host was kind of biased towards her, and he still
I'll check
dominated.
it out.
So let's.
But this guy, he's like the lowest 3 flat earthers, man.
All right. So if anyone was making a horizontal, just for future record, so we don't have to go through this whole thing again. If somebody was making a horizontal line and only had those 2 measurements, would we be able to glean anything from it, or would we have no idea what's going on in the middle?
You horizontal lines. I don't know.
What's up?
Go ahead, Mark.
Jeremy, nobody's making a horizontal line.
If
Simple
any,
as
just for
that.
the future, because there have been people that have claimed to see
Nobody will
horizontal.
ever claim that.
Well, since light is
People
You're
have
getting confused, Jeremy.
people have claimed to have made horizontal lines and seen drop from it with only those 2. Not even those.
The
2.
only way you could claim
But
it's
that's
actually
not this
horizontal
claim.
line is if you have it leveled out the entire length of it.
Well,
Oh, what are y'all talking about? Soundly claimed to make a horizontal line to the building, the Marriott building, and had 248.
That's what I
foot of
mean,
drop.
Rakia. Thank you, Rakia.
Thank you, Rekia, for derping in.
No, that was nice
Are y'all
work. Because
going
Mikey
against
literally
Soundly?
just said you guys never claim to make straight lines, and here we got Soundly trying to make
That's
it
not
a
at all.
horizontal
He's-
line.
Scott Mackey said he's talking about in this observation. That's not.
Yeah,
what
I'm
he's
just saying. I said for future when people do claim to have made horizontal lines, and Mackey said no one ever claims to have made horizontal lines.
Oh yeah, he's talking about in this.
Okay, well,
instance.
for the future, in any horizontal line instance, okay.
It's all about precision and how accurate you'd like to be. If you make a lot of measurements, you can be more accurate. If you don't make as many measurements, you're not going to be as accurate, but you can still
That's
come
not
to
the
a
case.
logical conclusion.
How accurate?
It's at what
Go ahead.
it's at what distance you make the measurements on how accurate it is, not how many you make. Because if you're making them over a long distance, and you're getting inaccurate measurements, it doesn't matter how many you make, you're still inaccurate.
No. I'm assuming when you make a measurement that it's accurate. What I'm saying is the
That's a
more
bad
measurements
assumption.
that you make, the more accurate you will be.
That's the whole ordeal. That's when you shoot over 24 miles like Soundly did and say your measurement is accurate and you're missing 248 feet of a building. That's not a good measurement. You can do it 100 times and maybe get the same measurement 50 times. Doesn't mean that it's accurate. It just means under those conditions, that's where it's hitting.
What we're talking about is atmospheric conditions, and if you
That's what I'm
just
talking about.
measure at the beginning and the end point, it won't be as accurate as if you made atmospheric measurements every 1,000 feet for 20 miles. You'd be way more accurate making more measurements in this scenario. But it doesn't mean you will be inaccurate if you only make 2 measurements. It just means that it's less accurate.
I got you. You're not talking about drop from horizontal measurements. You're talking about measurements of atmospheric conditions.
Right. That's what Jeremy brought to the table.
I understand.
I'm not trying to argue with you. It's just a different, slightly different topic.
Well, I understand. I was maybe missing that point, but let me finish mine, and then when y'all can go back to that. When you're taking measurements with a tool that makes a horizontal through the atmosphere over long distances, each tool has its limit, and depending on the atmospheric conditions of the day, even 400 foot is too far. So just keep that in mind.
It's limits for a particular measurement in question, and it's error bar.
Yeah, but almost every error bar that I deal with, at least, are plus or minus. So it seems when other people do it on the opposite side of the argument, they're always talking about just one error margin pointing down, and that's creating a sphere, and that's not it. When you go out and take measurements in the field, you're going to have plus and minus.
Plus or minus some degree, some like a half a degree or something like that is going to be the maximum. And so no, the observations that people are making over long distances, where more than that is hidden, like in say for a building or something like that, half a degree, for whatever size building it is not gonna be very much. That should be missing. Yeah, more than that's missing. So
I'd like to add that Jesse Kozlowski the other day, when Jose replayed his video, was talking about one time he did a long distance observation and horizon was above the horizontal line, and all through his career he's never seen that, and he thought his machine was broken, and in actuality it was just the conditions of the day. So every time people show the horizon being below the horizontal, they never show the ones that are above. That's just kind of been my claim for years, and people laughed at me, but Jesse actually backed up what I was saying again the other day. He's also
Go ahead, man. But he actually just backed up everybody else who said that he's a professional person who makes these observations, and he's only seen it once. So that means that it doesn't happen that often. People who are paying very close attention, he's only seen it once. So
he actually doesn't make long distance observations like that very often. You know why? His self-admitted saying that that's not what the tool is for. At that point, you're just turning it into an optic, like a telescope, because the crosshair is hitting an object that is not in its actual position. It could be up or down. That's his whole point. That's why he doesn't back up soundly. And when you ask Jesse, hey, when you point at the Adelaide crosshair at a building 24 miles away, and you say 248 feet are missing at the bottom due to earth curve, how is that possible? He'll say word for word, I do not claim that. And the reason he says that is because he knows it's not true.
Or because he doesn't claim the accuracy or the exact accuracy that you're claiming.
Yeah. Well, he's the one that was saying it.
Saying that he may not want to be accepting of the 248 quote unquote number. He might want to have an error bar on that of it's down, but it's down by between 10 and 15 feet. 248 to 238.
I'll find out for you how much of the building is half a degree from that distance on there.
Hey, Jeremy, are you still here?
Don't start, Pyro.
Oh, what?
If you are, say something good at least.
No, I was just gonna say, are you upset that you got rid of your Bitcoin or you lost your Bitcoin?
I didn't lose my Bitcoin.
I thought you bet it against Scott.
Yeah, $5. So what?
But that $5 could have been like what, $20 now?
It would have been $10 now.
It would have been like $10 or something. It was like 20 something. Whatever. If fucking Trump don't leave the White House on by the 22nd, V owes me $10. Or at least my own $5 back.
All right, Jeremy, I got something for you. I got something for your Punk ass. Just kidding. But I got something for you. Yeah, that building, whatever building it is, from the distance of what did I say?
What
Oh shit,
building?
hold on. Fuck, give me 1 second.
I
Hold
feel
on.
like I walked into the middle of an argument. What building?
Why don't you let him ask?
Story of my
What were we
life,
just talking
Jeremy.
about?
That was me.
Oh, my bad, Rakia, my bad.
The Marriott, yeah.
My bad,
with all
my
the
bad, my bad.
with all the compression at the horizon, the when the hotel
let him
floors are
talk.
compressing. Is that the one you're talking about, where all the hotels floors are compressing as they get closer to the horizon?
Yeah, that's the one he's talking about.
What do they call that compression?
Depression.
Perspective compression.
Perspective compression. That's a neat thing.
So Jeremy,
I just call it depression.
can you see the chat?
Yeah, I'm looking. Hold on.
Soundly
got it.
also says that he can see Earth curve with his 20/20 vision. So if you want to trust someone like that, go ahead. Fine by me, but I don't think that's possible myself.
Okay, I see a whole bunch of.
Okay, look at the first one, Jeremy.
Hold on. The first one at whatever 06, 08, whatever. that is.
08. Yeah.
We got A and B.
What you see is two angles, right? A and B.
The vertical lines are both of his theodolites,
Yeah.
right? Okay.
Yeah.
All right.
Well, so we're not going to talk about theodolites, right? We're just talk geometry, simple geometry. And if those two lines, those two black lines, if they are parallel, A plus B will equal 180, right?
That's right.
So if A plus B equals 180, then we can conclude that they are parallel if that blue line is straight, right?
Okay.
Okay, but if A plus B is greater than 180, what must we conclude about those two lines? The black
They're not
lines.
parallel. They're not parallel.
More than that, what must we conclude? The angle out,
That the
right?
plumb line wasn't accurate.
Just shut up for a second, Rakia. Gee, Rakia, shut the fuck up.
Yeah. Did the main surveyor make a? I mean,
Hold on, Jeremy. Let's
hold
walk
on,
through
this
this.
was all. This was all over what the main surveyor did, didn't he? Make a horizontal line to see if his lines were.
No. Exactly. This is exactly what he did. He took these two angles, right? He dropped what he called plumb lines.
How did he get those angles?
And the question, hold on. Let me finish, Jeremy. The question he was asking, are those plumb lines parallel, like in the first picture? Or are they angled out, like in the second one? That's the question being asked. Which one was it?
No, the question being asked is what kind of line did he make? Did he make a 45-degree line? Was he trying to make a horizontal line?
No, Jeremy, that's where you're misunderstanding. That's not the question being asked.
That was the whole point of the
No,
thing
it
earlier.
wasn't,
You guys said
Jeremy.
it wasn't horizontal.
Jeremy,
there's nothing.
you can deny the question being asked if you want to continue to misunderstand this, or you could try to understand the question being asked.
Okay, I have a question right after this question.
Okay, the question being asked is, if you add up A plus B, and it is greater than 180, what must we conclude about the two black lines?
That they're not parallel. My turn for a question. You ready?
Okay, yes.
In the main surveyor's thing, which angle was he using as that cross line? What was the angle of what was the angle of the line he made from A to B?
Doesn't matter.
You said it wasn't horizontal. What do you mean it doesn't matter?
Doesn't
this whole thing was
matter,
over.
Jeremy.
It wasn't horizontal. You guys tried to play me.
No, Jeremy, hold on for a second.
You tried
All
to
that
play
matters.
me.
Hold on, Jeremy. All that matters is what A plus B equals, right?
I mean, he's asking different questions. He's asking how did you determine what A or B was? Like either of them.
Did you make a 5-degree line? Did you make a
tops
horizontal
and he
line?
pointed at the same place.
Mountain tops? No, he was looking at two theodolites or auto stations or something.
Yes, I know. And where were those
Auto
things
station.
positioned? They were positioned at two high points on a geography, right?
Yeah, making a horizontal line.
No.
So we could-
See, even in my graphics, you notice that line's not horizontal, right? The blue line, it's not horizontal, right?
In your line, yes, but what did the main surveyor do?
Exactly like this. He had two lines. See my black lines? They're not even horizontal to each other. One is definitely higher than the other one. The one on the right's higher than the one on the left, right?
Yeah.
Because for this purpose, it is irrelevant if they're at the same height. I could have drawn one completely above the other one, right? And all that matters is the parallelism of them, right? So A plus B, if they are parallel, equals 180, right? The horizontalness, the elevation, none of it matters. All that matters
On
is
paper,
the
yeah.
parallel.
On paper, yes. On paper, yes.
Well, in reality too, in geometry, that's all that matters. So we'll just say on paper for now. So if it were the case that A plus B equaled 180, we can safely conclude that if the blue line is straight, then those two black lines are parallel, right?
Yep.
And so horizontal is irrelevant, right? The angles at which, the relative positions of the left black line versus the right black line is irrelevant, right? All that matters is A plus B, right?
Yeah, so what?
Okay. But if A plus B is greater than 180, we can assume that those two black lines are not parallel and they look like the second image, right?
Yeah, if they're more or less than 180, they're not parallel. So what?
But no, hold on. They're always more than 180. Okay. So we can conclude that if they're more than 180, that those two black lines cannot be parallel, right? And they must be
if they're more or less
converging
than
outwards,
180,
right?
if they're more or less
No,
than
you,
180,
Jeremy, stop with the more or less.
You keep saying
No,
the same thing.
stick with more for now, because that's what they always are. They're always more, and that's important.
That's not true. They're not always
more.
Shut up. I'm talking to Jeremy.
Guys, there's no
You're
need.
just wrong.
It's
It
not
is
correct.
true.
He's getting through. He's getting
You're
through
just
with it.
deceiving the audience. That is not true.
No, that is true, dude. So there's no need to butt in with that, man. There's no need to butt in with that.
That is not true. They're not.
You don't even know what he's talking about right now, Rakia.
Yes, I do.
By the fact that you're saying that, so just let him get through it with him.
No, I'm not. He's not telling the truth.
You done?
Yeah, if you
May I
want to say
continue?
they're always more, that's wrong.
Yeah, find a time when they're not, and get back to us.
I can take a measurement.
Find a
over
time when they're not, and get. Don't tell me what you can do, Rocky. Go do it and get back to us.
We've done it.
Until then, shut the fuck
I
up.
think he's talking about Rakia. Yeah.
Until then, shut the fuck up.
Okay, I have the
Because-
main surveyor's actual.
You keep acting all tough on this Discord.
I
You're
know.
lying
I
to
know.
people.
I'm
I
not.
know.
For fuck's sake, dude, I'm
Well, they
being
talk to you
honest.
like that so that you say
can't
something like, "I'll
possibly know
slap
what
the
he's talking
shit out
about
of you."
saying that. You can't possibly know what he's
Oh,
talking
you're a
about.
tough guy, they say.
No one's being
So,
tougher
Jeremy.
and acting tougher. Doing
Oh,
anything.
you're a
I'm
tough
telling
guy.
you guys.
Then
that
shut the
Scott Manny's
fuck
trying to
up,
explain
then,
something to you.
Kosho.
Scott
If
Manny's
somebody's
trying to
being
explain
tough,
to them.
shut the fuck up.
Dicks. Just close your mics for a minute.
Can I just real quick give you guys the main surveyor's actual results?
Okay.
Yes.
And show that he was actually making a horizontal line. If you could see in the chat, it actually says horizontal line.
Scott Mackey, can I ask about your pictures very quickly?
Sure.
Would it have helped in your explanation if you had drawn two lines, like one going one direction and the other going the other direction? Because technically,
But that's not what he did.
okay, he only did it from one direction.
No, he did it from both directions, right? He did it from A to B, and he did it from B to A.
That's what I mean. Like if you all right, if
It's
you're
the same
at A,
line.
then say again.
It's the same line.
Well, it's going to be intersecting, but it's not going to hit the same. It's not going to hit the same point, right? Isn't it going to hit?
Sure it is. No, he aimed it at the same point. That's
So
why
wasn't
A
just
is not 90 and B is not 90. No, they didn't try to go horizontal. He just, he went to point A and set up a station at 6 feet high. Then he went to
So you're
point B
telling
and set
me
up a
when-
station at 6 feet high from
when the main
wherever
surveyor-
it was.
When
And
the
then
main
he,
surveyor,
then he went from A and he pointed to 6 feet. He pointed to the station he put up at B. Then he walked over to B and he pointed to the station he set up at A.
okay, so when the main surveyor, hold on, Kosho, when the main surveyor wrote out this thing of his actual results, and they're both very close to 90 degrees, and he wrote horizontal line, he didn't mean horizontal line?
That's at the base of the level. It's not the line of sight, Jeremy.
He didn't mean horizontal line there. We should probably send him an email or something.
No, you form an axis at the level. That's what it's referring to.
So he's not referring to a horizontal line.
It's not the line of sight.
Reference line, dumbass.
I'd like an email sent to the main
What's with
surveyor
the
too, and ask him how
dumbass
he
and all this
verified
shit
that
talk,
his
man?
lines were verified.
But Kosha, you're not involved when that happens.
Can I finish this
Jeremy.
though, Jeremy? Because you get this refraction thing
Right,
coming in,
just
which
get
is
involved when
gonna.
someone says shut it
And here's
down.
why your refraction is irrelevant. Because in the second two, I have refraction in there. It's not a lot of refraction, but it's enough to get the point through. And if we compare the image 1 to image 3, right? So both parallel lines, the first one has no refraction, the second one has refraction. Now, whatever A plus B is in the first one, which we determined is 180, A plus B in the second one is going to be less than 180, right?
Sorry, which one are we looking at? 108?
Okay, let's look at 3, the third one I posted.
At 108?
Yeah.
The third one from all of them, or the third one from the one post?
The third one that I posted. The one at 108, the one that has another, that looks like the black lines are parallel. Because they are.
Bro,
and as you can see,
you posted
that
4 pictures. 2 of them were in separate posts.
3 out of 4.
Yes,
From the
third
all
of 4.
of them. So what?
Okay, so you see that line on the third of the fourth posted is curved, right? A little bit. And so if those lines are parallel, which they are, A plus B is going to be less than 180, right?
Well, we got an issue real quick before we can move on. You took an angle measurement from a curved line?
Well, we resolved a while back, Jeremy, that all that matters is the angle at which the light hits that measuring device, right? And so the angle is the absolute instance of that interaction, right?
That's a good point, Jeremy.
Right, but in this picture we're talking about, you took an angle measurement off a curved line.
No, Jeremy.
It's not curved? The blue line's not curved now?
You can do that. It's allowed.
Jeremy, we've been through this before.
It's allowed, Jeremy. Come on.
The blue line is
curved. It's curved,
a representation of something that nobody can actually see, right? Because that's
Instead
the path.
of calling it the blue
we're
line,
talking.
let's
Hold
just
on,
call it the
Jeremy,
curved
hold on.
line.
Let me. I'll explain this. The blue line represents the path that the photon took from
The
B to
curved
A.
line.
And from A to B.
The curved blue line, right?
Yes, and so whatever's reading that photon hitting at A is only going to see the very last angle that thing makes. It's not going to see a curve, right? Nobody can see the curve. The curve is invisible, literally.
So how close should we measure the angle?
Soundly can. 2020.
Shut up.
Did anybody record that? Nobody can see the curve. Thank you.
I got it recorded. I got it recorded.
I'm a baller.
Guys,
Stop being a dork.
I'm trying to get this with Jeremy real quick, man. Just I'm almost certain you don't even know what they're talking about, Rakia, because you think it's.
So how far out?
They're talking about doing this measurement thing. So
it doesn't matter, Jeremy. What we would do is when you point a theodolite or some kind of device at something else, what it's going to do is measure it's going to measure the angle at which that photon hit that lens, right? That's what it's measuring. True?
Only measure it at the last length.
It'll just measure the very, it's an instantaneous angle. It's essentially zero length. But
I'm not comfortable with this taking this angle measurement off.
Jeremy, that's how optics works, man. We've been through this.
Okay, let's move on. I just want to object to this point, and we'll.
And so that theodolite at A is going to be pointing well above B, right? That's just the way. And then the reason it does is because that photon path is curved in refraction situations.
Is anybody in here shocked that when you use optics to make a measurement over long distance, the further you go, the worse the measurement gets? Is anybody shocked now after all we've talked about? So what a shocker. The more you move a plumb line away from each other, the more
can you shut up for like 10 minutes? Is that possible?
That's almost
is
shocking.
it possible?
Yeah, I was on mute for a long time listening to your nonsense. See, every time I
can
stop
you stay
talking,
there for a little while longer?
Watch.
Is it possible?
Because you want to spout some more nonsense on how when you take a measurement using an optic over longer and longer distance, your measurements get further and further apart and get off more. And how do you verify those plumb lines are plumb, by the way, with any plus or minus accuracy?
It's always the same.
But that's not what I'm doing here, Rocky. If you want to talk about that,
and then maybe he can answer your question. But
About
let him get through this first.
when real men take real tools.
Let him
go
get
out
through this,
into reality
Rakia, and save that
and
until he's done.
establish
Man,
plumb
for real.
lines. How do you know that those plumb lines are exactly plumb and to the zenith and not off? How do you verify that?
Why don't you save your question so he doesn't have to do that until he's done doing this?
Sit behind y'all's computer. Don't go out in the real world and do it.
You
What
done?
else you got? What else you got for me, Mackie?
Well, I just want to. So, in picture one, we agree that A plus B is 180, right?
If they both add up to 180, I don't know. Hold on.
This is just simple geometry, Jeremy.
Yeah, I gotta
This
go
is
back
just
to your
lines on a
pictures
piece of paper.
Right, I gotta go back to your pictures to see what we're looking at.
Yeah,
Okay, the first picture, A plus B equals 180.
yeah, we agree, right?
Oh, well, I mean, I don't have a protractor or nothing, but if you say so, okay.
But they would have to be, right? If those two black lines are parallel and the blue line is straight, A plus B has to be 180, right? As simple geometry.
Sure.
Okay, and in picture three, with a curved line, and if we're measuring the angle at which that curve hits that line exactly, not anything in between, just that very last angle, A plus B is going to be A plus B is going to be less than 180, right?
I'm still wondering about this angle measurement right here.
This is just geometry.
Yeah, geometry.
I'm just
says
imagining
that if you're
curve
gonna,
hitting that line. Sorry,
don't get where
I
you're
did
where we're
not
taking
know
this.
I was not muted.
Don't worry about where we're taking it. Well, let's just talk about geometry for a second, and then you can conclude whatever you need to from it.
In geometry, can you take an angle measurement from a curved line?
No, it's straight lines, right?
Yes, you can, absolutely.
You can?
Yes.
At the angle of incidence.
Yes.
All right, so what?
It would be less than 180 for parallel lines. It never is.
So, but we agree that if that
But
line was
why is
curved
in
and
the
we can take
diagram
an
the
angle
line drawn
of
as a
incidence
curve?
exactly where it hits that black line, the blue line hits the black line on both ends, we're going to get A plus B less than 180, right? You agree to that?
Are we assuming curvature? Is that why that line's curved in the diagram?
Refraction.
No, it's the light. It's the light curving.
Oh, thank you.
It's a photon path curving. It's not it's.
Yeah, because the photon.
But we agree, Jeremy, right?
The
Less than
photon
180.
is in straight lines, right? It just bounces off of molecules to appear curved.
So you're measuring. Hold on. You're measuring the angle the photon hit. Did they measure this in a picture? Like how do you get this measurement? I'm just wondering.
That's literally what optics is, Jeremy. If you point
optics is taking angle measurements from
yes,
curved
if you point a theodolite at something, you are literally taking the angle measurement at which that photon hits that receptor. That's what it is.
That's not what he's asking.
But that's what it is.
All right.
So can I get an agreement on A plus B equals less than 180 now?
If the lines aren't parallel, yeah.
No, the lines are parallel, right? In this picture, it's the
lines are parallel and they're.
It's the photon that's bending.
So are you
the photon path
accidentally
that's
admitting,
bending, right?
Is this what I'm hearing? You're admitting that the angle that we're seeing is because of optics.
Do I need to turn up Sofa King to see what he's actually saying?
I was asking a question. I wasn't trying to be rude. Fuck.
I can't hear a word he's saying. I got him muted.
So the plumb lines are
If you're admitting something, but no, he's not admitting that. He's not saying that.
Okay, so the plumb lines are parallel in this third picture we're looking at, right?
No. I didn't say plumb lines, right? I said lines. These are just lines on a piece of paper.
The lines are
We're just
parallel,
talking
yeah.
geometry here.
Right.
And
the
these black lines are parallel, and this
All right,
blue
that's
line
what
is
my problem
curved
was.
on the third picture. A plus B is going to be less than 180, right?
If you say so, all right.
Well, no, I need your agreement. This is just simple geometry. This is like geometry that 13-year-olds do.
Oh, really? What calculation do you use to measure an angle from a curve? And when you're 13.
Dear Lord.
Jeremy, you're gonna resist this
You don't
hard,
take
right?
into account the whole line, just the angle of incidence, though, right?
Jeremy, let it go, man. Let yourself learn.
Okay, so we got two parallel lines.
Oh
and
my
a
God,
curved line in
Jeremy. Come
We got
on.
two straight lines and a curved line in between them, and it's less than 180. Okay.
Yes. And so what we can
Okay.
say is that on the curved line, the A plus B is going to be less than on the straight line, right?
All right.
In all cases, A plus B will be less than the straight line, right? On a curved line. And so now if we compare image 2 to image 4, we have the same veering out of the black lines, and we have a straight line versus a curved line. We could see in that picture, A plus B of the curved line of 4 is going to be less than A plus B of 2, right?
Mm-hmm.
All right.
Okay, so here's exactly why refraction in your protestation never matters, or it can't matter. Because whatever refraction was in there, it's going to make A plus B less than the straight line. But you still have in every measurement, A plus B is still greater than 180. And that is even with refraction. And so that would make those two lines even more
Even
non-parallel.
further apart.
Right.
That's
But we
just
have
what
what we
must
do have.
conclude mathematically, geometrically. If you have refraction and you have A plus B still greater than 180, you have an even greater unparalleled between the black lines.
So now that
And
we're
if we say
counting
those
refraction,
black lines are plumb lines, then we have an even greater deviation of plumb lines.
so now that
With
now
the-
that
Then
we
you
have
have to,
refraction,
if they're plumb lines,
because of
I
gravity.
was going to say, if they're plumb lines now, it's a different story, right? Because now we're dealing
But
with.
you see how this works out, simple mathematics.
mind.
This is very basic
Found ever or
geometry,
no?
right, Jeremy?
we
There's
have
no way you
refraction-
can dispute this.
Is my mic on?
Yes.
He just treats people like that, dude.
Now that we have refraction in the mix, we're gonna have to know which way the light's bending in between. Right?
Oh, so you're suggesting that the light may be bending down, the opposite of what I have.
You're suggesting it might be bending up.
I'm suggesting that's
We
the
don't
only
have
way
a
that it
measure.
bends.
Would we need a measurement to be able to tell?
No, you make an assumption, bro, just like every other Glober argument.
No,
Do we
we're
need a
making, we're
measurement
actually
to
making
know,
assumptions
or-
straight.
Well, that's why he drew a curved line
Would we need
in
a
the
measurement
diagram.
to know, Mackie, or no? Or you just want to make an assumption and call it a day?
Because now you can bring you to the plumb
We've
line.
assumed straight, actually.
No, you're assuming
No,
that.
no.
The
If you
light's-
want to
you're
say the light
assuming that the
always
light's
doesn't.
bending down.
Yeah. How would that happen?
Consideration of what happens.
If the Earth was
Stop
curved, you're assuming a
assuming.
curvature because the curvature of the what do you call it? The gradient
Explanation
of
for the rainbow type arc.
atmosphere.
We have no explanation
creates
for
that
the
that exact effect. So if there
downward
was
arc.
no curvature to the gradient of the atmosphere, we would see.
But most
something
likely at the
different.
elevations he took
So he is
these
assuming
pictures,
curvature,
this
not letting you get
guy,
away
this
with it.
main
And I'm a
surveyor,
baller.
that line was
Yo,
straight.
Scott, you
It's
gotta
like image
unmute
2.
other people. You can't just have people muted and then talk over them.
Oh, who was talking? No.
He knows
sorry.
who's talking.
Well, I'm not unmuting him. But
Just turn him down low
Well,
so
then,
you, at least
then,
you know when
then
he's
you'll have
talking.
to,
I'll
you'll have to
watch
get
his
yourself
light.
muted then, because that's just not how it goes in this room. No one is
Well,
allowed to do
actually,
that.
you did interrupt
You're not.
them, Glenn.
You're not special. We don't mute
Hey,
each other in
Grim.
here without getting told.
Yeah, well,
where's
they
the
can
ball?
deal
getting
with
told.
you. I'll
Where's the
mute
ball?
Mackie for over talking you if you don't bitch and moan about me muting you when you're over talking everyone else. Deal?
No, I don't think Mackie should be muted either.
Deal, Grim?
I don't think Mackie should be muted either. Why are you
Hey,
going
well, then
against
guess-
my fucking principles?
Guess what, Grim?
Yeah, you think I'm
Shut
stupid
the
enough to
fuck
go against
up,
my own
Grim.
principles?
Yes.
It's not my rules. It's Jim's rules.
Grim, shut the fuck up. Quit over talking.
Whatever.
You should be
dude.
muted for having someone
Quit
turn
mumbling
down.
over
talking
people.
over
as
you.
well.
Matter of fact, Curved, it wasn't me that was over talking him, right? It was
I've
him
been
that muted
listening
me.
to
I
you,
took
Grim.
my
I've been listening to you muttering over people the
I took my-
entire time.
I took
Shut up.
I took my turn. I took my turn. All right.
At that one
And I-
time. That one
Yeah,
time.
this is the
That's it.
Back to
Yeah,
the
okay,
data.
let's move
Back
forward,
to the
guys.
data.
Come on.
yeah.
Deflect
I've not been
against the
interrupting
argument.
people.
Hey, Jeremy, did you hear Rakia earlier? Rakia said that Jesse, the surveyor, that he in his entire career had seen that effect one time. So it's fair to assume that when an observation like this is made, the light's being refracted, it's being refracted in the direction that it usually is being refracted.
Yeah.
That's not
Can I?
what
So
that
we went
says.
from making measurements to making assumptions. That's fine. If you wanted this to just be another one of your assumptions and not definitive, I'm fine with that.
Good. Jeremy already picked up on that. So that's what I was trying to say. I didn't know if you could hear me either, but that's what I was trying to say was now that he's got you to realize, to talk about this curved line as if it doesn't matter, he'll bring you to the plumb line idea and hope that you don't think about the curved line again. Right. So
the curve.
Right. So we're assuming the curve in the first place.
The light is bending.
And we're assuming that too. Exactly. Yeah, Rocky, you're right. And then, so for that example, like, so it's like, well, that's how refraction works on a curve, right? So what if it's not a curve and refraction is working differently than that? I mean, I think that's their question. There's not.
Have we ever
you just can't
assume? Let me ask this. You say it's always bending down and we're seeing it higher. Fine. Have we ever made a straight line over? Have we ever? What?
It almost always, not always, but almost always. Yeah.
It's almost,
okay. Thank you.
I misspoke.
This
you
is
say
what
it's
said,
almost always.
said, yeah.
Hold on. Almost always bending down, and we're seeing things higher. Have we ever made a straight line over distance to verify this?
Foreground looming.
Or are you just guessing shit again and assuming?
It looks like when you crack open this nutshell here, inside of it is an assumption again.
One of the trolls, sit back for a second, because as I said, Rakia had stated that Jesse, the guy who's been, he's an older dude, he's a professional surveyor, he's seen this one time. That tells you that this thing it's possible, it's not impossible, but it's almost always refracted in a direction that it's usually refracted in. So when you're making an observation like this one, it could be that freak day that this is happening.
You're conflating the point.
Probably not the only one day that this observation was made or this measurement was made.
No, this is the older surveyor that doesn't do a lot of long distance observation with these tools because they're not used for that. And on that one time he thought his tool was broken, that he did do an observation over long distance. The few times that he has, the horizon appeared above the horizontal line. Doesn't mean he's been doing it all his life and it only happened that once. It means he hasn't done it that many times because he's a smart surveyor. He would never use this tool over long distances.
Makes sense. It's been accurate.
Thank
for
you,
that.
Jesse. Thanks,
How often
Jesse.
did it happen over short distances?
Short distances, 300 and 400 feet, these tools are very accurate.
And how often does this happen? Did he say?
Over a short distance, you're not going to see it either way. The whole point is when you go into greater distances that the accuracy gets off because of the reasons that you're stating. You're saying that you always has excess because the light bends up. That's bullcrap.
This test was done at 500 feet, wasn't it? And is that a long distance?
Sounds to me like if
yes.
Why wouldn't they just use it? If it was accurate at long distances, why wouldn't they just use them for long distances then? That's the point.
It sounds like it was 500 feet. Is that right, Mr. Moyak?
That's what I recall, but I could be wrong. That's what I was asking him. Was it over 500 feet? Because he seems to know about this measurement.
That's less than a tenth of a mile, right? That's fine.
There's been several tests done, and I can't remember which one this one was.
Comments from the guys who are barely listening in?
So assumes that your plumb lines are perfectly plumb and no plus or minus in those also. It's a lot of assumptions.
Right. That's the thing is you need a flat place to prove that a mountain can alter the plumb lines. But then when you're on a mountain, you assume that you have square plumb line. It's like craziness.
Mountain affect your plumb lines.
Oh my
Mountains change size.
The thing is
every fucking time.
I respect geodetic surveying. The thing is, to me, is you need to complete the circuit, right? If they're just doing little micro observations, there's wiggle room. You need to complete the circuit and prove that the circle went all the way around. Thank you.
This was done both directions.
Like taking a photo of Earth from space.
This was done both directions.
Oh
Don.
wait, that isn't gonna work.
Mountains are not going to affect the plumb line.
I don't know what you mean by that.
Except for the gravity, and that's not going to give you the kind of thing that's going to be observable like this, especially if it's not a giant mountain. So the mountain's not relevant really. They could have done it lower or higher, but the mountain's probably reduced refraction or something. 500 feet, you're not going to have any weird refraction that's going to affect it.
What I'm trying to say is this tiny piece of excess that you're going to find might be argued that it's the tiny piece of gravitational differential. You get what I'm saying? You know, there's some.
So
everywhere
now gravity is a
we
thing.
have some little tiny piece of differential. Right?
Listen, guys, the Earth is fucking flat and stationary. What don't you guys understand? Honestly.
Yeah. What's so hard about that?
He's trolling you. Yeah, he's expressing.
No,
his,
it's definitely flat. Whether he's trolling or not doesn't matter. It's definitely flat. It does matter. It has boundaries at the edge that hold in the waters, and it has land masses that rise out of the water in the middle of that basin. Very simple.
Fucking fallacy. You just need so much fallacious reasoning to think it's a globe. No fucking evidence. No, all this doubtful shit.
That's right, man.
Okay, Kosho, I believe you now. You're right.
Yeah,
He's
of course,
fallacious. You're right. You've been right all along.
No, we're not here for y'all. No.
Percent
Y'all
statement.
please.
Yeah.
Did you see the picture I posted?
Ballers. No.
It's an extreme version. It's not a reality-based picture, but it's just to explain why the curved angle behaves the way it does. Because these lines are parallel, but an extreme angle like this one, you can see that the angles, even though they're parallel, it's going to be less than 90 degrees on either side. That was what he's trying to express.
Look. I've been listening to you lot going on for a while now. It's getting tiring. Just what's the problem? What is the problem? You know what I mean? Some people think,
you want to hear it again?
Some people think they are. You think there's plasma out there. Some people think there's a vacuum. Some people think that they're lying. Some people think there's astronauts up there. Some people think they're in the water. It's all over the place. We all just need to just talk science, real science.
Plasma out there is real science, knucklehead.
Well, yeah.
But you have a lot to answer for. Brummy, you have a lot to answer for. What the fuck are you doing wearing red trainers? Look at this.
Red trainers.
This is a fucking outrage. Explain.
Dancing around in the park.
It's no surprise that Brummy's behavior is disgraceful all around.
It's actually hilarious.
Yeah,
everyone likes that. They're my running shoes. Is that from
that part?
What effect has the discovering the Earth is flat have on your
There's
runs?
that part.